Good morning, everyone. This is Archana Haylock from OCP, and welcome to the Tech Talk series from OCP. We are here today with the Rack and Power group and the team and the volunteer leads and all the speakers. Have worked very hard to put together an amazing agenda over the next 3 hours. I have a couple of housekeeping things here. First of all, this call is being recorded and all the slides and the recording will be available later this week in the OCP past events page on our website. If you are not speaking, we would really appreciate it if you go on mute. That will help with the quality of the recording. If you have questions, please, you can do one of two things. You can post them in the chat, or you can also wait until the speaker is done speaking and then raise your hand. You can get a little hand raise icon from the reactions portion of the Zoom at the bottom of your page. You can raise your hand, and then the moderators, Hamid, Justin, Caleb, Steve, Colin, they'll they'll take your questions and repeat them and pose them to the speakers. With that, thank you so much and enjoy this wonderful session. Justin, Hamid, you're up.
We're ready to take over.
Rock and roll.
Great. Well, everyone, good morning, good afternoon, good evening, depending upon where you are in the world. Thanks for joining us. I'm Justin Blumling, and I am a project co-lead with the Rack and Power group. I share that spot with Hamid. Hamid, do you want to say hello?
Yep.
Hamid is there, and Caleb Lusk is also here. Caleb, you want to say hello?
Yes, hello, everybody. Thanks for joining.
All right. Well, thank you very much again for joining. We want to say first, welcome, and that's what the next slide is. And thank you very much to our presenters and community members. As Archana said, we think that we have a really great agenda for you today, talking about all of the developments in the ORV3 community. You can see the number of great presenters and their representative companies here. So a lot of great thought leaders, forward thinkers who are here to give the entire community an update on the progress that the group has made over the last several months since we all got together in Santa Clara back in November for the 2021 summit. So we've got some group updates to share. There may be some names on the presentation, the intro slide, that may be unfamiliar. We have Steve Mills moving from the incubation community lead for Rack and Power to the Advanced Cooling Solutions, which we also call ACS for short. And we are pleased to introduce on this call today our new IC lead for the Rack and Power group. That is Colin Dupree, who's on here. Colin, you want to say a few words, just introduce yourself?
Sure. Hi, my name is Colin Dupree. I'm the Vice President of Technical Operations for Sony PlayStation. Specifically, I work on the kind of cloud streaming side of things. I'm relatively new to OCP. We've kind of just begun our OCP journey, and I hope that that kind of non-hyperscale, more enterprisey perspective can be beneficial. But I'm happy to be here, and thanks to Caleb, Steve, Archana for placing your trust in me, and I hope I live up to it.
No doubt you will. Thank you, Colin. One other change to note is Caleb Lusk, my coworker at Rittal, has been a faithful lead here, a co-lead with Hamid in the Rack and Power group for a number of years. Caleb has taken on some additional roles at Rittal, specifically being a design engineering manager. So he is got a lot of responsibilities internally at Rittal. And so he is going to be the outgoing Rack and Power project co-lead. But will still be involved with the group, albeit in a more reduced role, so that he can tend to the many tasks and projects that he's currently undertaking. Caleb, you want to say a few things about your time in OCP so far?
Yeah, appreciate that, Justin. Just everybody out there in the community, it's really good to see so many participants again in these tech talks. It's been a strong 3.5 years as a project lead, but plenty of involvement prior to that, and there'll be involvement in the future too, down the road. So I'll just be a little more in the background. But I just wanted to say, thanks again to the whole community for really allowing me to serve in the position and serve you as a project lead. So it's been great, and look forward to where the project goes, and definitely look forward to staying in touch with many of you. So I look forward to the rest of the day too. Thank you, Justin.
Absolutely. Thanks, Caleb, for that and for your service over the past 3 years. So I've been the one doing all the talking so far, or most of it. So for those who haven't met me,
sorry, Justin, if I could jump back in, just again, a welcome to Colin and taking this on. Do appreciate that. I would like to give a shout out to Mr. Mills. So thank you for definitely the leadership within the project that you've given us over the many years. So I just wanted to get that out there too. Thank you, Steve.
No, it's been great given the opportunity to represent this community for the incubation committee. And I want to give a special thanks to you, Caleb, for your help and support over the last couple of years. You've been instrumental in our ability to grow this project from where we were many years ago to where it is right now. And the fact that I'm moving on to the new cooling environments position is kind of testament to the growth that we've had inside of this group over that time period. So we really appreciate all your help and leadership in that. And welcome to Colin. We're excited that you're here, and really interested in the new perspective and background that you're going to provide to the Rack and Power project as we go forward. So thanks for joining us.
Thank you.
Great. Well, thank you for that, guys. So with Caleb as the outgoing project co-lead, I have stepped in to be the co-lead working with Hamid. So I'm Justin Blumling, relatively new to the Rack and Power community, and looking forward to serving and hopefully, continuing the engagements like this where we get to bring the community in and talk about what we're working on and also get your feedback about what our priorities should be in the future. Just to give those new to the community and perhaps those who have been in the community before, just a background about the mission and significance of this group. When the original charter was written back in 2012, you can see that we talked about the Open Rack design as being a foundational technology for other open compute designs and projects. When the most current charter was written in 2017, you can see that word foundation recurs and is repeated. And then the current charter listed a series of goals that you can read and see there below. And so that's what we're proud of here in the group. And that's kind of our mission and significance, is that when Meta all those years ago talked about the need to kind of redefine hardware and to kind of paradigm shift what hardware looked like and how hardware was serviced and supported, and how to make the data center more efficient from utility entrance all the way through, what happens in the rack. The rack fundamentally and the power distribution within the rack needed to change in order to achieve that disaggregation of the individual components, to enable the service flexibility, to enable greater energy efficiency. So the rack is the foundation for that. The rack and its power distribution enables those goals through the reimagining of what data center hardware looks like and what data center hardware could be. So that's what we try to enable here. That's what the projects and the subgroups that we have try to achieve. So that is sort of our North Star and guiding light. When we look at what our focus areas and work streams should be, or what they are today, it's the rack system architecture, which consists of, the rack frame, fundamentally the mechanical aspects of the rack frame to start. And then underneath of that, there are sub-focuses for facilitation within other project groups, right? So if we think about advanced cooling, the rack has to support, the future cooling manifold designs and the future rear door heat exchangers that are talked about in some of the cooling projects. So we have to make sure our rack is, seamless with integration of those components. We have to think about the data and power interconnects. So making sure the rack facilitates that easy connection of those pieces. And we have to think about hyperscale and enterprise design considerations. So how do we address both segments so that OCP increases its footprint? We also have to think about shelves and adapters. So what are the optimal form factors and attachment for the IT and power hardware? How do we make it as easy as possible in order to deploy the hardware technology and make it easy to service? On the power solution side, of course, the fundamental tenets there are the power shelf, the battery backup, and the bus bar, the integral components of power distribution within the rack. And also, of course, in our purview is the AC and DC power interconnects, just like the data and power interconnects are within the rack frame. And a really exciting part of the group is the management layer, which is the rack management unit, which is a really interesting piece of technology. And we'll have presentations on that particular technology, as well as all of these work streams today. So that should be really interesting to hear what the latest developments are coming out of those subgroups. Here's what our agenda looks like today. So we are in the middle of the first part, the welcome agenda and mission. I won't read through all of these, but you can see that we've got a variety of updates from each one of the project groups, from the rack frame through the power components to the interconnects. You can see here on the second page, going up through approximately 11:05 a.m. Pacific time, we'll have the ending with the 48-volt bus bar connection, our 48-volt bus bar design. And then after that, Hamid and myself and Steve will try to have some open discussion, community feedback, and then wrap it up here in the last at the last section of the day. So, and since this is a virtual event, we can continue to chat after the conclusion or after 11:30 Pacific time if people would like to, because this is a community. We're all about the exchange of ideas, and if good conversations are happening, we want to continue to facilitate those. So with that said, a big thank you to everybody who's here. Again, thank you to the community. Thank you to the companies who are participating. And then let's get on to the speakers. And I believe first up is Mr. Steve Mills.
Yes. Let me switch over here. Okay. So can you see those okay?
Looks good.
All right, thank you very much. So I'm going to go through a quick overview of all the specifications that we've got in progress right now. The project has quite a few things going on right now. So this is just a quick discussion of what we're doing right now, as well as some schedule related things for the OpenRack V3 family. So kind of the first section of this is going to be the base specification. So this is the minimum requirements necessary for interoperability in between the components, the minimum amount that's required for anything that's part of the OpenRack V3 family. So first of all, we'll have one around the rack frame, including like bus bar locations and CAD files associated with the rack itself. We'll also have one around the power systems, which will include, voltages and dynamic response management, those types of things. And then we'll also have one for the IT gear design guides. This will be mainly focused on people that are building gear to be compatible with the rack itself. And then finally, we'll have a specification around the bus bar mechanical interfaces and how that subcomponent interacts and is connected to the rack frame itself. So all these will be available, at least right now, in September of this year. So again, these are all like the very minimum requirements necessary for interoperability amongst the system. So the second set is just supporting specifications. So these are specifications that will be available, but they're not necessarily required, but you could use them for reference if you're building components. So the first one is we've got the AC input connector specification. We've got one for the 48-volt DC output for the power shelf. We've got another one related to the IT gear and how it interconnects to the bus bar. And then finally, we've got one for the AC power cord. So these four will also be available in September of this year. And the goal of these is really just, if you're interested in using these, you're welcome to it. But obviously, if you're developing a 50 kilowatt or 100 kilowatt bus bar or different power shelves, you may need different interconnects and power cords in order to make that happen. This is what we're going to have in September. And then finally, we have some Meta specific product specifications. So these specifications define exactly how Meta is going to consume this gear. So all of these specifications comply with the base specification, but they'll add Meta's requirements on top of it. So these will also plan to be available for later this year for the community to reference as they see fit. So that's kind of where we are right now. Let's see, I've got another minute or something before we move on. So I can turn this over to the next presenter. I believe that is Daryl.
Yeah, that's right. We've got Daryl Daniel and Steve Moore, who are slated to give us the rack frame update as our first product segment. So we can turn it over to them. Steve and Daryl, are you there?
Yes, we're here.
Hey guys.
Go ahead and share my screen.
Thanks, Justin.
Okay. Hopefully everyone can see this okay.
Yeah, looks good, Daryl.
Okay, great, thank you. Hi everyone, I'm Daryl Daniel. I am with Meta Platforms and I'm a mechanical engineer on the hardware engineering infra team. I'm going to be joined today by Stephen Moore, who is a program manager with Rital. And today we're going to go through some of the design updates since we last presented at the OCP Global Summit last year. All right, so Open Rack Charter objective is essentially providing flexible solutions capable of scaling across different industry needs. And so one of the primary goals in moving from ORV2 to ORV3 was providing that flexibility. So ORV3 has more provisions to address diverse needs of rack consumers from hyperscale through enterprise. So essentially we've attempted to design the rack in such a way that it can be configured in many different ways with more flexibility versus ORV2. This next slide here kind of gives a really good overview of some of the differences between ORV2 and ORV3. So with ORV2, the power delivery was 12 volts. With ORV3, it's now supporting 48 volts. We can put power shelves in any rack slot. So with the ORV2 design, there was specific locations in zones within that. For power zoning, there is no zoning within ORV3 that, like I mentioned, those power shelves can go within any slot. And so you can configure it any way that you want. There are toolless rack rail designs, whereas in ORV2, they were bolt in. They're now clip in the V3 design. V3 also supports RU gear in addition to the OU gear. That allows maximum flexibility for different OCP members, depending on what your configuration needs are. to support whatever gear you need within that. So that's new to the V3 frame. For the gear quantity supported, so in V2 it was 40 OU with no RU support. In V3, we're not, the plan right now is to not define an overall rack height with a specific number of OU or RU slots in it. So each end user can configure the rack to tailor their needs in terms of the overall height and the total number of OU and RU slots supported. For the initial rack that Meta will be deploying, right now our plan is to contribute a design with 44 OU and 47 RU. The rack itself could technically support 48 RU, but as we don't plan to use that top slot, we're gonna block it off effectively to prevent airflow bypass. But like I said, the design could support up to 48 RU physically. And we're also providing modular rack cabling solutions. So in V2, the cable managers on the front of the rack were fixed. In V3, they're bolt-in solutions. And so you can customize each rack with different cabling options if you need to, based on whatever configuration in the rack you're actually using. So it provides a more flexible modular solution with regards to the cable management. We are going to be providing support for optional a rear cabling backplane for those who might need it. So that's new to V3. We also have a movable cross brace in the V3 design. In V2, this was a welded in member, and so you couldn't move it around within the rack. So it did limit somewhat the actual configuration of the IT gear within the rack. You had to kind of go around that. In V3 design, that cross member is movable within a certain range within the rack. So it gives you a little bit more flexibility in terms of how you stack your IT gear within that rack. The overall payload weight for the IT gear has increased from 1,400 kilograms up to 1,600 kilograms. Again, this is just looking forward to next generation systems, which tend to be heavier as we get into liquid cooling, AI, ML applications, things like that tend to be more dense and packed with gear. We're also providing along those lines, kind of looking forward-looking into the future, cooling manifold support within the V3 frame, and then also rear door heat exchanger support within the frame itself. Just recently, we updated the reference 3D CAD models on the V3 wiki page. So everyone's free to visit that site and download the 3D CAD models. The model that's currently up there is a 6 OU section of the frame. It includes the movable cross braces. It includes the IT gear shelves for both OU and RU, as well as the power shelf rails. It has the bus bar profile in there, and then all the relevant frame members. You can see as well, so with regards to the OU and RU support for those IT gear shelves, there are different notches on those inner vertical members, which those rails clip into. And with the OU, we actually have a little bit more flexibility where there's notches every half OU. So it even gives you a little bit additional flexibility in terms of how you place your product within the rack. You can actually use those half OU spaces as well as the full OU. Likewise, similarly on the V3 wiki page, we're also including a 2D PDF drawing with a cross section of the rack, which provides some of the relevant dimensions and tolerances for some of the primary interfaces. The data may that's referenced in the drawing is where your latches for your IT gear would clip into. And then the rest of the interfaces to the bus bar and to the manifolds, to the hard stops for the IT gear are all referenced off of that primary datum. So again, I invite everyone to check out the V3 OCP wiki page, and these files are available for you to download as needed. All right, so what are some of the changes that we made to the rack since we last met at the OCP Global Summit last year? One of the changes we made is we made some modifications to the OU and RU labeling that's on the front of the rack. And this is really for integration of the racks and making it a little bit easier to know where you're actually installing your IT shelves and your power shelves and things like that. So we've changed to a color-coded labeling system to help distinguish between the RU and the OU. So it's really just a usability improvement on that. There are some future plans to integrate potentially some labeling directly to the inner members as well to help while positioning some of those racks within the frame. We made some slight improvements to the blind mate manifold mounting brackets. And these are essentially improvements in the fitment and the constraints of those brackets to improve the positional tolerancing and the angular control of those brackets, which affect the manifolds and how they interface with the IT gear. The leveling feet have been redesigned for easier removal and installation. We have a toolless installation method on these leveling feet, so they can be replaced if needed, if they get damaged during shipping and transport. So we have a toolless design on that now. We've made some changes to the vertical cable managers that are on the front of the rack. So some of the updates there include additional mounting holes, mounting patterns for the cable clips, as well as some of the cable tie lance features. So we've added some more of those and shifted the positions around slightly from the last update. On the bus bar, we also made some changes from the previous design. The geometry of the bus bar itself has been improved. And this results in some increased stiffness, torsional stiffness in the overall bus bar design. We've improved how it mounts to the rack and in terms of the different hardware that we're using on it. And then we've also increased the chamfer lead-in on the bull nose of the bus bar to help with mating of the IT gear connectors as they mate and engage with that bus bar. For the side airflow containment gaskets, we've made some changes there. Tighter, smaller gaps to prevent any additional airflow bypass around the rack. So we've made some tweaks on those. And then we've also changed how those are mounted and fastened to the rack frame itself. Still a toolless design for mounting those. We've stabilizer kit. So depending on how your rack is configured and the overall payload and where that center of gravity within the rack lands, you may need to use stabilizers to help prevent the rack from tipping. So we've got a stabilizer kit designed. We made some changes to it so that it installs easier onto the rack. This is also a toolless design for both installation and removal. And then finally, we've defined and prototyped some front and rear security doors for the rack for those installation locations where extra security is maybe needed. Those will be available to the community. All right, at this point, I'm gonna hand it over to Stephen Moore. He's a program manager with Rital, who's been doing a lot of this early development, and he'll kind of go through some of the details of the changes that I just talked about.
Brilliant, thanks, Daryl. If you don't mind, if you just continue sharing, I'll go for it on here. So
Yeah.
Some of this stuff does overlap with Daryl's, but it gives you a good sight of what these things look like visually, and I'll give you some more details around each part. So here we're looking at some of the stuff that's happened recently, such as the cable manager trays, which Daryl mentioned. As he said, there's been some features added into those cable managers to accommodate some of the accessories that do go into that feature on the rack. Just to the right of that, we have the cooling manifold interface kits. So as you can see, the parts which are highlighted in red in those renders, one sits at the top of the rack inside of the frame, and one sits at the bottom. And the benefits of doing this as a component is we can use this as a kit and not burden the cost of the frame. So that's how that's been designed, and that's the purpose of those parts is to hold the cooling manifold for the cooling configuration rack. So that's what that is there. And then included in part of that also is the middle beam there's a middle component to it, and that was added to the frame, or the kit, should I say, to support the deflection we were seeing in FEA analysis of the cooling manifold and its bracket. So all three of those components are part of that kit, and that obviously will be sold in the future for anyone who needs that configuration. And then just on the far side of this page, we have the movable center brace. So just an image there to show you that the middle beam brace, which is needed for certain loaded configurations to hold the frame in structurally sound. This can be moved up and down in the rack by plus or minus 5 OU. It is worth noting we will be doing tests to confirm kind of what the limits are for those different positions. And right now the hope is that obviously we would have the same load capacity for each of those positions. So that is one of the focuses right now, which I'll touch on later in this presentation, but these are some of the recent updates. Okay. So next, this is some images of the front and rear doors, which Darryl mentioned. As you can see here, the images are block red, but those doors are actually perforated. So you would have airflow there for these doors specifically. They do open 90 degrees at the moment, no further. So that's how they're currently designed at the moment. I suppose it can be discussed if anything more than that's needed in the future. And regarding the locking system, so for the front door, we have a 4-point locking system, which is very secure. It's something that we do as a standard here. And then on the rear split doors, there's a 2-point locking system to the frame, and then the center line of that split door, typically obviously that is central, but for this rack it's slightly offset of center due to the buzz bar being in the central position of the rack. So yeah, this is the doors that we have been working on for the kits. Okay, next is the side panel. So this is it's a very basic component. As you can see here, it sits inboard of the vertical members on the side of the frame. The main purpose for this kit is airflow. This is fixed with screws into the frame, but there has been we have looked into a secure side panel with locking features as well. But what you're seeing here is the basic screw fixed airflow side panel. So this would come in a standard kit, or it could come with a frame as such, and this is how it's positioned in the rack. Okay, next, this is some images of the side flow airflow gasket that Darryl mentioned earlier in his table. So as you can see, it's a very basic design, a flat piece of rubber seal, which is fixed to the rack with a sheet metal component to keep that uniform, and then fir tree fasteners to fit that to the rack into holes preset into the frame to accommodate these seals. So, and Darryl, you correct me if I'm wrong, this would be positioned at the rear and the front on one side for airflow in the future. Is that right?
Yes, that's correct. We will have a gaskets on the front and then in the back as well. And we're still looking at where those will be positioned right now on our implementation of the rack. We're planning on one gasket in the front and then the 2 in the rear for the hot out implement.
Great, thanks, Darryl. Okay, next. So here's some images of the stabilizer kit. So this is specifically to pass the 10-degree tilt test. That's is a standard requirement for any racks in deployment. It's used to move a rack around the rack, either empty or obviously if it's loaded with servers as well. So as Darryl mentioned, it is a toolless design. So there is a plunger and mushroom feature which allows you to just slot this into the side of the frame, pull it along, and then the latch, the plunger pops into a hole and it holds it steady for when it's being used, and then it's easily removable also. There's some handle features, as you can probably see from the image here, which allows for the safe lifting of this component once we're ready and complete with the move of the frame. So yeah, this is, as you can see, there's also as well the addition of safety labels to explain how to use it, so that anyone, even they should be trained, but if they're not, they would understand how to use this product in the data center. But here we have another recent, well, fairly recent update that we've done is we've added a cable grommet for cable entry safety. This is at the top of the frame, so there's a number of cables that can go in here, mainly the power cable. So this has been introduced to protect, obviously, the cables entering around the sheet metal edge. I have been told that the plastic of this component, specifically that we're looking at supplying right now, has a 50% recycled material in it, which is good for recyclability. And we have done a fair amount of FEA analysis on this. One part of FEA analysis that we did was for the snap-in features to ensure that this is secured properly and isn't too difficult to assemble. So that was done by Paul Clements, the lead designer for the rack development, along with Daryl. And then we also did some flow analysis for the mold tool process. This was done by the supplier to ensure that the product could be made exactly to spec to meet the requirements that we defined. Okay, yeah. Okay, and then just one of the things that we have been doing is there's not necessarily an update, but it's just a touch on some analysis that we had to do for the shelves. So we completed FEA analysis of the IT shelves for the rack. And this was specifically looking at the displacement of the shelf and the IT shelf when you were putting the equipment on it. So we're looking at some higher, heavier server loads right now. We needed to make sure that the shelf would not deflect so much that it would fall into the lower OU position, causing configuration installment issues. So the requirement was that we would not displace the shelf edge down below 0.2 of a millimeter under level. So we did some FEA analysis, some point load analysis, and as you can see, there was two individual point loads. One is the first point of load, which was on the 89-degree position of the shelf. That's where the equipment would be in contact initially, and then obviously as that deflects down, the point of load would change to the far left-hand side of that shelf. Where it would obviously become stronger, and the FEA showed at the higher levels of the equipment, we indeed did get a pass, which was good. So for the OU shelf and the power shelves, we've proven out with FEA analysis that we would not get an issue with the highest levels of load for these shelves. Great. And then just to touch on the current focus for us at the moment during development, we're deep in testing and validation, the final kind of the large final group of testing that we need to do before entering the PVT phase. So this is a lot of testing right now. We're right in the middle of it, and we're aggressively trying to stick to the schedule to get this all passed and approved, which is good. We're also reviewing and finalizing tolerances. So we've done a lot of TA work for this rack, and we're just kind of coming to the final stuff now, leading up to a design freeze where we're just kind of tightening everything up and crossing the I's and dotting the T's. And then we've also been looking at additional FEA and rail deflection under load. So even though I mentioned earlier that we've passed the main tests, there are some tweaks and potential considerations that we need to also analyze to make sure we cover ourselves on all eventualities in the field. We also looked at additional improvements in airflow gasket seal. So that's still an ongoing development that we've obviously sent samples out. We need to have a review cycle on that, and then there may be updates coming on the seal. And then finally, detailing concept designs for optional accessory kits as we've kind of gone through. I mentioned the security side panel. Also, additional airflow containment panels may be needed for specific requirements. And then also seismic bracket does need to be looked at. Okay, I think that's everything. So did anyone have any questions? I think we're just out of time actually. So
Yes, Steve, oh, sorry, go ahead, Hamid.
Yeah, I like to say there has been a lot of good questions on the comment area, and I see Steve is helping with some of the answers. I am not sure if the comments on question and answer are saved. I like to see, we have like maybe a couple of minutes, give you a couple of minutes for any unanswered questions.
Yeah, I agree. Steve, I think the comments that you've been, or the responses that you've been contributing about 19-inch equipment support is probably a very relevant question to a lot of people on this call. Would you care to just expand upon what you put in the chat?
Yeah, there's questions related to, does OpenRAC V3 support RU gear directly? And it's the same paradigm that we had in OpenRAC V2. You need some sort of adapter because traditional EIA gear, 19-inch gear, is assuming RU height and AC power inputs. OpenRAC, of course, is 48 volt DC, so you need to have some sort of adapter to handle that, as well as the additional width. So there's while we don't have a plan that to contribute to any of that, there's nobody working on that I'm aware of right now. That would definitely be a valuable thing for someone to go off and develop that adapter for contribution. But the paradigm would be the same. We are putting some features inside the racks that allow the 48. The RU rack builders to put their existing gear into those spaces, so they can get a rack configurations that's the same level of density that they would expect in a traditional EIA gear, but it still does require that adapter. And there's also some questions on here about the security doors and side panels, what the material is made out of. So Steve Moore, can you answer that question?
The side panel specifically, did you say?
Yes.
DCO1 steel, the side panel would be made out of, yeah.
I think there was another question that came in about the liquid manifold. HISA was looking for an example of what servers, any OEM, ODM servers you're targeting to be racked. And also, is there any particular requirement for the data center facility? So can someone address that?
I can talk to that. So they're in the cooling environments group. We moved all of the liquid cooling components into the cooling environments project. So we will have lots of detail around manifolds and that type of information on, I believe it's the 24th of May and 25th of May. We would be doing all of the same type of tech discussion related to the cooling environments group. So I would tune into that to get all those questions answered.
Quick question, does the chat area being recorded? Like, people can later see the chat question and answers,
Yeah, we'll find out and we'll get back to you on that. I believe it is, and we are recording it. But anyways.
Okay, thank you. Thank you all and the speakers, Steve and Daryl. I think we can move on to the next presentation, Justin, which is, I believe, the PowerShelf update from Harry and Lam.
Yes, correct. Thank you, Hamid. And thanks to Daryl and Steve for the previous presentation. I think it's well worth spending the time on the rack frame updates, because we get a lot of inquiries about it. A lot of things that we talked about today in between the summit and today. So great job, you guys, and thanks for explaining a lot of the developments, the great progress you've made. The next session is on the PowerShelf update, and I believe that starts with Harry from AEI. Harry, are you there?
I am here. Can you hear me?
Sure can.
Fantastic. And see, I'm gonna share my screen and see what you guys see. This is interesting because I've got multiple screens here. Let's see how that works. Okay. Share screen. Okay, share. Okay. Do you guys, okay, I'm gonna go into the presentation.
No, we don't
mode.
see your screen.
Do you?
Now we see it.
Now we see it, yeah.
Okay, so I hope it's not a split. I'm gonna change the settings. Okay, sorry about this. I'm just trying to figure this out.
It's
So
working now. That's fine.
it's working? Is
Yeah,
it
looks great.
full screen?
Nope.
Oh,
now
now
it's
we
switched.
have the other. It was okay. Now we have like your side.
There you go. Now you
Okay,
can-
is it better?
Yes.
Yes,
Yep.
don't touch it.
I won't touch it. Promise, Archana. That's it. All right. So now we can get rolling. My name is Harry Soin. I'm a senior technical marketing director for the hyperscale space, and I will be providing an up and of course for working for Artisan. Now it's part of Advanced Energy and located here in the Bay Area. And I will be providing an update along with my friend Lam on the ORV3 Power Shelf, which you've been developing. All right. So the key areas that we plan to cover today is of course, which is one of the most important areas, is the efficiency. If you may recall, I did an update in the previous session on the earlier version of the units, and now as we get into the DVT stage, so we'll be providing an update on the DVT units. I will be talking about the rectifier to BBU transition. We've been working here with with the customers as well as with Lighton and Delta in working to take it to the next step, take the key learnings as the design improves, add those features in. Then I'll touch a little bit on the automated integration setup, which really is the key as we get to test multiple cases, corner cases, and so on and so forth. All right. So here, as you probably can see on the screen, is this is an update on the pre-production units, the efficiency update on the pre-production units. On the efficiency. So, you can see that so how we did this is we randomly selected 6 units from the DVT build, and we went through all the cases, minimum efficiency across all the points and everywhere else. And in fact, if you see the curve, there's multiple lines and they're all sort of lined in together. So all in all, they are performing very close to each other. And, we are, I'm glad to say we are like 97.75. I hate to claim 998 because that's a big step, but very, very high efficiency. It's 97 consistently across all the units. And all these data measurements correlates with engineering and customer efficiency measurement setup. So we have been consistent, and we not only meet the spec, we exceed the spec for the efficiency, and that's going very, very well. Moving on, just want to recap the one area where we have worked very closely, especially with Meta, and glad to report that AE has done a significant contribution in this part in helping to understand, this is a key part of peak shaving, how we transition from rectifier to BBU and how the unit performs. Just for a recap from the previous part, the BBU triggers when the rectifier voltage drops by 3 volts. That part hasn't changed. What has, however, changed is, previously there was about 4 milliseconds to trigger BBU, and when we start to share. And during that time, output will adjust when the 66% of the energy was depleted. And the other condition was the average power was more than 3.3% for 10 seconds and 3.6 kilowatts. I apologize, for 100 milliseconds. So these are like peak shaving conditions when this is the overpower conditions, right? And there's an envelope for the repetitive peak pulse power for up to 150% of the load. That hasn't changed. However, what we looked at is single pulse power, which was more than hold up time for overload conditions. That is the area we try to change and adjust. So here is an example.
Harry, before you move on,
sure.
If you go to the previous slide, we had We had an update on the spec. Yes, the single pulse power has removed. Yeah, the other one has changed to 50%. Oh, okay. You
Correct, correct. I was just gonna get into that right now.
Oh, okay, okay.
Perfect. So what I want to bring to the condition is we have taken the single pulse power out of the design based on the feedback and testing and working with everyone else too. And in order to do that, what we have done is the output will adjust. And how do we accomplish that? That is done when the output will adjust if the 50% of the bulk energy is depleted. And it's more energy dependent. And I'll show that in the next slides. And in order to do that, the level to trigger is 6 milliseconds compared to 4 milliseconds as we had in the past. So that is really the key. And I'll talk a little bit about the advantages. Why do we do this and what are the benefits? So before I before I get into those details, I just want to show the real measurements of the units. So, as you see a transition here, right, to meet minimum 6 millisecond, the bulk energy depleted. So you can see that the trigger was set down to, like I mentioned, we are talking more of the energy. So it's 30 joules is what AE is designing to. And the spec, I believe, is 27. So we just wanted to have more margin. And this is one of the extreme conditions when there is 150% of transition, okay, of the load. The spec is actually 5.67 milliseconds for this condition, but like we have a margin for energy, which is 30 versus 27 and 6 versus 5.7. As you can see that the unit performs very well. This is the transition. The voltage drops down, BBU takes over, and everything works as expected in this condition. So this is what I was trying to say here is if you look at the spec, we have taken that single pulse out, and the advantage here is here. So I'm just so why we remove the single pulse power adjust? The problem is by removing this condition, it allows rectifiers to be, less susceptible to the output adjust under. So if or false triggering, we don't want to do that. So, as you can see here, as a rectifier in the previous case would trigger, as soon as we exceed the hold up time at, for an example, at 18.18 milliseconds at 110% of the load, which is not desired condition. So what has happened now is as we have moved on, here is an example of all the conditions and the benefits, as we take that condition out and adjust for 50%, for this load condition. So here you see when the load goes from 110%, 115%, you can see the actual time to adjust. It's 103 milliseconds, and all the way down to the worst case, which is the 150% DC to DC peak load, you still have the time to adjust is 21.59, which is more than the actual hold up time. So the spec time in this condition is 16.28, and we have margin there, and you can see under all the conditions we have adequate margin for this operation. The orange light shows the comparison versus the spec, so we are performing well under all those conditions. So all in all, so up to 150% of the load, step from 100%, we can get greater than 20 millisecond of hold up time before any adjustment, before the output ever adjusts, right? And the condition here, like I mentioned again, the spec is 24 joules. Instead of the energy or the time, we are just focusing on the energy level of 24 joules. And, we have designed with like 30 joules in mind so that we have margin in place for these conditions. So moving on, here is a setup that I just wanted to showcase and cover. That as we get more into the DVT stage and get near production stage, we have to look at the corner cases. We have to do a significant testing with BBUs, with 2 power shelves and two sets of BBUs. So we have all the setup is ready. In fact, the team, this is a slightly outdated slide. We have started to get into more details and collecting the data. And I plan to share that with you all during the next opportunity and the next case when we get into the details and cover more of the corner cases as we progress with this design. Moving on, finally, I just want to show, what we, at the end of the day, what we've been working on at Advanced Energy. We have designed the 1OU ORV3 power shelf. Here is the on your screen. So this is the front view, and this is the rear where, you have your bar clip connector. We have a single whip design and a dual whip design. So either we have two positronic input connectors or a single input connector. We have designed working on power supplies from 3 to 5 kilowatts and perhaps planning to exceed 5 kilowatts if happens. So, currently 3, 4.5, 5, those are in works right now. And a 2OU shelf as well. We are moving ahead with a 2OU shelf as well for this design. So that brings me to the end of presentation, and I'm open to any questions from Hamid or anybody else.
Yeah, I just want to add a comment about why we changed it from 66% to 50%. The reason, yeah, it was a little down planning, but the main reason was to give more time for the BBU, and it is more for the reserve, especially at 150%. Before was 4 milliseconds. With the 50% is right now around
5.7.
Yeah, 6 milliseconds. The batch spec is 4 milliseconds. We just give them added another 2 milliseconds for reserve, and that was the main reason to make sure we have a smooth transition.
Perfect. Thanks for clarification, Hamid.
Thank you for the update. That was very good. Let me see. There is a question from Joe. It says 2OU shelf appears to have a different input connector.
Yeah, that's a good question. In fact, see, as you go up, 2OU shelf is supporting a higher power. So we are looking at the Harding connector to support the higher power for AC input versus positronic. Does that answer the question?
And the follow-up, it says, what kilowatt does it support, the 2OU?
Say that again.
What kilowatt, how much power?
Oh, the good question. So the full capacity is, we plan to go onwards of 60 kilowatts. We are designing this with higher power supplies in mind. So ideally with 5 kilowatt power supply times, 5 times 12 is 60 kilowatts. That will be the raw power. And we can talk about whether it's N plus N or N plus 1. So a maximum total of 60 kilowatts is what we have in mind when we design the shelf.
Yeah, thank you with that. No other question on the chat. If anybody has a question, you can unmute yourself and ask.
Hey, Hamid, to address your question about the chat transcript, it is available and it is being recorded. So we will upload it along with the recording.
That's great. Yeah.
Okay.
I think there's a good range of question and answer for later on to people to see.
Yep.
Greg is asking, is there an expected maximum kilowatt per rack? I can answer this question. Sure. So the power shelves, like that you see here, is either 15 kilowatt or like 33 kilowatt is the power shelf. But on the rack, in theory, you can put more power shelves and make them in parallel. The power shelves, they have the feature that you can actually you can plug in from there is a cable from plug in from one shelf to the other one, and they do parallel sharing, current sharing. So you can add more power shelves in the rack. It's just a matter of managing the cables. I think as you add more, the cable management would be problematic, especially on the side. We only have two cables that we can fit in on each side of the power shelf on the rack. So On the power shelf, there is, I think we have not tested up to how much we can put the power shelf in parallel and it still works fine, but it has the capability. That has to be identified. The main piece is the managing the cable management, power cable management. I think with that, we can go to Lam. Hello, Lam, and for the presentation from Lytion. Thank you, Harry.
Hey, how are you? Harry, can you let me share?
Okay.
Okay, you should be able to see my screen, yes?
Yes, we can see your screen. Go ahead.
So I don't continue with what Harry present. So I'm just don't want to repeat what he said and just go to talk to other part that he has not talked about. And so the OIV3 right now specify 3 kilowatt, but we are also taking this same specification and we develop a whole range of power supply ranging from 3 kilowatt to 5 kilowatt in the same form factor as defined in the OCP OIV3. And we also develop a power supply that's a little bit longer in 5.5 kilowatt. And we also recognize that some other application in 19-inch rack also want to use the solution as OIV3. So we also develop develop a family of product that for the 19-inch rack, because of the PCB that we developed already gear up for 68 millimeter. So we set these same electronic in a smaller, a narrower box that will fit into a 19-inch rack application. And it's also, we can lower the height 1 millimeter, so that's going to fit into the 1 RU power shelf. And for the power shell itself, you know, because the power supply is conformed to OIV3, so we can configure the power shell differently. And as you can see, the power shell has the 7-pin connector, so it will accommodate, you know, 208 delta, 240 delta, or 415 or 480Y. And with us, we have both solution power shell for 1 RU and 1 OU. And we also have a power shell that have additional C13 in the back of the power shell, so that you can have only one whip come into the power shell and you can power other top of the rack equipment. And we have some requests of having more power in the shell. So our power shell also in the back of it have connector that you can daisy chain them together to allow you to parallel between power shell. And we also developed a power shell that is used in the immersion liquid cool with our partners Submer. And these power shell will have the front access, so that, you know, when you put the power shell into the liquid cooling tank, then you can still access all of these connector, all of the input power and everything from the front. Okay. So this is some of the picture example of the power shell. This is 1 OU power shell, very similar to what Harry had shown with the SIG power supply and PMC up front. And the 2OU shell, we also did some of this, developed some 2OU shell for some customer. And that we said that, you know, because it's a more power, so we use a different type of connector. For the 1RU power shell, you know, this is a 19-inch. So we're gonna have a narrower power shell controller, but the PSU itself is gonna be 39 millimeter. And then this is the power shell that for immersion liquid cool application. So you can see that all the AC input is at the front, and we have shell controller, you know, in a corner here. And in this application, because there's more power required, so we put a 9 power supply here. And this is a 3 kilowatt, but we also going to have a version of 5 kilowatt. When you talk about, you know, what happened if we want to parallel power shell, and we run some tests, and we can show that, you know, with the daisy chain current sharing connector, the power supply between power shell can have a current sharing less than 2%. And in case that you don't connect don't have this connector connected, or the connector disconnected, then the power shells with the droop feature still can share current. And but in this case, the current share going to be worse. It's going to be less than 10%, but still within the boundary that you can work with. So that it will be all of the update that I have for the community in terms of what are we doing with these ORV3 power supply.
Thank you, Lam.
Any questions?
Yeah, hey, Lam, I have a question for you. Good morning. Could you address any efforts that Lite-On's done across the industry for interoperability with power supplies from other suppliers?
We had been working with other vendor in different programs that have the interop requirement. And we had implement some of these between vendor. So in order to, in our opinion, in order to have the interop between vendor, then there will be a certain specification that the system designer need to give to different vendor. And one of them is to specify what is the time response, the filter between the actual current to the iShare signal. And if all the vendors will have the same time response delay, and their current loop internally can match this time constant, then I think all the different power supply can work together. Or that is what we experienced in some of the program we had been working through. Does it answer your questions?
Yeah, I think it sounds to me like this is something that's at least being driven to, but it's being driven, you know, on a case-by-case basis versus something pushed through at I guess the level that we're at here now with this, where it's more driven into the OCP requirement or spec. Is that fair that this would fall maybe more as a direct requirement, you know, for each application, or do you feel like this is something that eventually may find its way into the OCP space?
I cannot answer for OCP, but I think you are correct that at this point, there's no concerted effort to drive all the OCP to have interop with each other. But with under some specific program with some customers, then those are the requirements, and we will work together to achieve that.
So Lam, it's Harry Swiner. If I may have answered that question. You remember we did a part of the interop subcommittee, and we did work with you and with Delta as well on this, and we have a specification in place, and this was based on the ORV2 platform, and we published that, right? And that is very applicable, and just like as you pointed out, it uses especially the current sharing part, and we build all those hooks in place so that we can easily apply to, as we get into the DVT and beyond, we can apply that to and do the interop. And I guess that's what people want to see, that all of us are able to share and without any issues at the end of the day, right? Because we're working together on this effort.
And just to add, as part of the OCP and spec, we are trying our best to have a spec that naturally follows the interoperability.
Right.
It's kind of in the progress. I think we are going to do some of the PSUs from different vendor and start experimenting, and to see if there is anything else we need to add to spec to make sure the interoperability works naturally. The spec, if you see here on the V3 compared to V2, is more detailed, especially on this area. So the vendors follow the same in and out, and like current share bus, etc., to make sure the interoperability happens.
Yeah.
So it's not done. It's not done deal yet, but we are working on it.
Yeah, but we have hooks in place. I believe I agree, Hamid. We have hooks in place to take it forward.
All right, we are slightly behind, but that's okay. If there is not other question, Justin, we can go to the next presentation. Thank you so much, Lam and Harry.
Yes, thank you, gentlemen, for that contribution. Up next is the battery backup update, and that is starting with Richard from Delta. Richard, are you there?
Yes, let me share the screen. Do you saw my screen?
Yes, we can.
Yes. So hello, this is Richard Chen from Delta Taiwan. I would like to introduce our current Open Regulatory BBU product development status. And as we know, the ORV3 is a 48-volt power distribution system. It has 51 volt power shelf output and the 48 volt BBU shelf output. And the power shelf has 3-phase input, and we can use the 6 or 3 power supply to do the output current sharing to achieve input current balance. And also the BBU provide a backup function to maintain the output demand from the IT device. So when AC is available, and then the PSU could regulation the output from the 51 to 50.5 volt. And in this condition, BBU is in the standby mode and charges its output capacity close to the red bus bar voltage. And once the AC outage and the PPU, the power supply could drop by 3 volt. Once output voltage lower than 48.5 volt, it could trigger the BBU to enable the sync stop of the BBU from the standby mode to the discharge mode. When AC is recovery, the power supply will sync stop and increase output voltage to provide the power to IT load. And BBU can go back to the charge and the standby mode. And this page shows the power BBU shelf spec. It has a 6 BBU full installation in the BBU shelf and the reserve 1 slot for the BMI or BMC device for communication. And in the discharging mode, BBU output can maintain regulation output voltage from 48 to 47.5 volt, and provide a 5+1 redundancy, and for the 4-minute backup time, and after 4 years. And they have a more bus and for the communication. And in the charging mode, we can adjust each BBU of the charge current from the 1 amp to 5 amp. So the total input power from the bus bar is around 33 amp. And here we show the BBU operation mode. When the BBU is in the transportation or not installed in the BBU shape, it will in the sleeping mode. In the sleep mode, we need to have the power saving function. That means we have very, very low power consumption to maintain the battery energy. And once we install the BBU into the 48 volt BBU shape and connect with the 48 volt, then BBU will go into the standby mode. Once this voltage is higher than the 48.5 volt, then allow the BBU to recharge. Once we detect the BBU, the SOC label lower than our setting number, then we're going to the charge. And once we got the full charge, it will go back to the discharging mode. When the BBU operation in standby mode or the charging mode, once we find the bus voltage lower than 48.5 volt 2 milliseconds, then we will transfer to discharging mode. And then we provide the power to the IT load. And once the AC recovery will go back to the standby mode. And if the system can send out a command to the BBU to let the BBU force them to in the discharging mode, or we do the firmware update function also. That's a system control mode. And also if the BBU, we want to do the learning test to check the capacity, we have the SOH mode. We go into the SOH mode to do the discharge, to calculation the capacity to maintain, to update the SOH information for the BBU. And this page is showing the block diagram for our BBU. We can show here we have battery pack, we have BMS function here, and they can provide each cell voltage and current to our DC-DC controller. And also we have the discharge converter. It can regulation the output voltage from the 48 to 47.5 volt. And also we have the charge converter. They can charge the battery in the constant current or constant voltage mode. Internally, we also have the bias power to provide the bias power for the housekeeping and also for the fan. And the DC-DC controller is to get the information from the battery pack and provide a communication to the system, use the RS-485 Modbus and also the CAN bus for the BBU to BBU communication. This page is showing our charge and the discharge testing efficiency. You can see we can achieve more than 98% for the discharging mode, and we can achieve something like 90% for the charging mode. When we have the battery in the standby mode, you can see the cell. If we full charge it is the 4 volt, and we can in the standby mode, we can have the 90 days to have the battery voltage power distribution to 3.9 volt more than 90 days. And when we do the dynamic load in the power shift label, for example, we put a 5 BBU in the power shift, then we do the power shift, BBU shift label dynamic. We can check the 10% to 100% or the 50% to 100% or 20% to 150% or the 0% to 50% to 158%. We can see the minimum voltage is higher than 96.5 volts. And if we have the 2 BBU, we want to have the more power output, we have the 2 BBU shift in parallel. Then we have the 12 BBU, 2 BBU shift, 2 PMC, and the 1 TOR switch, and and we utilize 2 DC chain cable to do the communication. 1 DC chain cable is for the Modbus, the other one is for the CAN bus. So the Modbus is more purpose to do the communication with the TOR switch and report the BBU function the BPU information to the TOR switch, and also receive some comment from the TOR. Then we can have the change the discharge time, or change the charge current, or also do the phone upgrade. And for the CAN bus, we can do the communication. For the BPU to BPU, we will know how many BPU in these two BPU shape group, and we can consider the condition for the redundancy, and also have the sync stop and the sync stop function to do the discharge transition. This page shows we have the 12 BPU in two shifts for the current sharing. We can see we can achieve less than 3% current sharing performance. And then when we have the BPU and the power supply shift, we use two BPU and the two power shift to a transition. We can find a test result like this here. When AC voltage drop, you can see the BPU of the 48 volt bus bar voltage will from the 51 volt drop to the 48 volt. In this short period, BPU will help to the transition. You can see this is one of the BPU output current. And then if we take the two BPU output current, we can show even in this transition, the BPU can also do the very good current sharing. Now, when the AC is recovery, you can see the power supply can turn on together to provide the power to the IT load. You can see output voltage from the 48 volt, the increase to 51 volt. And also we conduct the SOC accuracy testing. First one, we do the full charge capacity check. This number is we do the measurement from our outside equipment. And this is our DC-DC controller do the calculation. You can see our capacity error and the SOC can within 2%. And when we use the constant load to do the SOC check, we do the discharge like a 3 kilowatt. You can see we do the discharge, the SOC error can less than 1%. When we do the 1.5 kilowatt load, the constant load, we can see the SOC less than 1.5 and 700 less than 1.5. If we do the dynamic load from the 62 amp to 31 amp, then every 3 seconds, we can see based on this test result, we can find the SOC, we can maintain less than 1%. If we consider something like random load, not a constant load change, then we can see that when we do a discharge, we can see that this SOC error can less than 2.5%. And also we complete the mechanical stress testing for the ORV3 BPU and their shift, like including the package and the non-package condition. Based on this test result show, we have a positive result for this mechanical design. So we have development of ORV3 power solution more than 1 year, and also evaluation our product. We find actually the open rack V3 power architecture provide a simple, reliable, independent control between the power supply and the BPU, and also provide a good transition behavior for the power supply and the BPU. And for the BPU can achieve the peak efficiency more higher than 98% in the discharging mode and higher than 95% in charging mode. And also we show here we have a very good dynamic response, just similar with the power supply performance. And these things based on the current BPU architecture, since we have the discharge converter, it can help the regulation of voltage. So it allowed us to use the different cell to do the to have the BPU in parallel operation. So we don't need to take care of, we cannot have the different cell to do the in parallel operation. So I think this is the board of my presentation today. Any questions?
Thank you very much.
Yeah.
For that presentation. Hamid, there is no one from Panasonic on the line with the presentation. Is there?
I think, yeah, they decided not to present. So it's
okay.
Delta that's going to present. I have one question. On the previous slides, you talked about this OC and the error. Can you elaborate more why the different approaches get different level of error?
Okay. So what we're doing right now is first thing is we have the OCP table, I mean the open the open circuit, the voltage. That we have a table based on the different temperature, and then we do the counter based on the load condition. We do the coolant counter to check the capacity reduced from the doing the discharge, and also we have the SOH. They can help us to update the SOH data. Based on that, we do the several times testing for this one. I think this one we have to work with the Meta team to update and improve our calculation method. Till now, we have this good result to show with the OCP.
I see. There's a question from the chat that says, is this product currently available for others to purchase?
Right now, we are in the DBT stage. Probably we can, I think we have the sales team contact window here. You can check with them to see if we can sample available for other customers.
Okay.
Yeah.
Any other question for Richard? All right. Thank you, Richard. Appreciate your contribution to OCP.
Thank you.
Yes, Richard, thank you very much. Next up on the agenda next up on the agenda is the RAC management unit. And we should have some colleagues from Google and Meta to present that particular topic. So if you guys are available, please feel free to share and kick it off.
Yeah, sure. 1 second, let me share my screen.
It looks like Sudhindra, you are on mute.
Sudhindra, we can see your screen, not a problem, but we just can't hear you.
No, we can't hear you. Maybe there's a problem with your earbuds. Umesh or Lingjun, would you guys able to start while Sudhindra trying to fix this problem?
Yeah, so maybe we can go to hardware part then, right? Right, Lingjun?
This meeting is being recorded.
Yeah, maybe we can go to this next slides.
Yes, can you hear me now
Lingjun.
or no?
Yeah, we can hear you now.
Oh,
Yeah.
okay. Okay. So yeah, my
But now we don't see the screen. So hopefully you share the screen and it works.
sure, yeah.
And we don't see your camera either. So I don't know if you're sharing your camera or not.
Now you're muted. So hit the unmute button. So then, no, we can't hear. They can hear you. They can't hear you.
So maybe we share present the slides and he talks. That's good.
Yeah.
Umesh, do you have the slides up? Maybe you can share your
Yeah,
screen.
let me check if I
Okay.
have slides.
And then that way, then Sudhindra can just join.
Yeah, okay, let me get this.
We can see your screen, so don't know if
Okay,
you have
yeah.
anything proprietary.
Yeah, okay, I have the slides up here.
Yeah, can you hear me now or no?
Yeah, we can hear you now.
Okay, yeah, sorry, I think I had to join the Zoom back. So yeah, Umesh, you can control the slides maybe.
Yeah, okay, I'm on the first slide, right? Okay.
Yeah, can go to the slide view.
Yeah.
Can you go to the slideshow, like zoom in?
Yeah.
Okay, so sorry about that. I think there was some Zoom issue. So I'm Sudhindra, I'm engineering manager at Google. Today we have Umesh, who is a hardware engineer from Google, and Lingjun from Meta. So we'll go over some of the rack management device overview, what exactly it is. And I presented this in the last session. So this is sort of continuation of where we are and what progress we have done so far. So just to recap, current OCP, the rack monitoring, there is no dedicated rack monitoring device today. The functionality is kind of split between top of the rack switch and the and the TOR. So what we see on the right side is the OCP TI rack, and we can see that there is no rack monitoring unit. So TOR does the proxy functionality, and all the data aggregation is implemented in the battery backup or the battery and the power shelves. So what we are essentially proposing is the dedicated box, which is RMD that integrates both data aggregation and proxy into one. And it also can function as the standalone switch. And also, since it is standalone or 1 gig switch, it can be used in the various configurations. And goal here is to make it as the TOR independent design, because today the TOR needs to do the security proxy in the current rack monitoring. So the TOR always need to run some kind of rack monitoring software or the proxy for that. So the design proposed here is the independent of that. And also it will have all the functionalities of the existing RMD, and also it can be used as the out-of-band management switch. Next slide, Amish. Yeah, so these are the high-level goals. The goals are still the same. So the main goal is the security here. It should have the hardware root of trust. And also we want to enforce the secure boot. It should provide the attestation. So this is kind of this device will anchor the security for rest of the peripherals, like say batteries and the rectifiers or the PSUs. As I mentioned, it is a TOR independent design, and TOR can become completely off the shelf then, because there is no security proxy or the rack management code running on top of the rack switch. It will enable off-the-shelf integrating off-the-shelf devices or the server securely. So we are proposing Redfish-based telemetry and the Redfish aggregation. So as long as the batteries and the rectifier units, the BBUs, emit the telemetry in the Redfish, then this device will aggregate it. So that way there is a standard towards how the telemetry is exported. And also there is rack level management network, which is, say, again, out-of-band management network we would like to create using this. And another important goal is, since it is 1 gig device or a 1 gig switch, it should be a low cost device. So because it will be one per rack, and we want to minimize the cost of that. So with these goals in mind, these are like, we are proposing some designs that we came up with, both from Meta and Google, which will meet these goals. These are very high level or very preliminary right now. We need to go through so many discussions, and on the components or on the details we need to figure out. So with that, yeah, Lingjun, you can go over the Meta specs.
Thank you, Satish. Yeah, my name is Ninjun. Yeah, I'm come from Meta. So I'm going to just share with the team that this RMD spec from Meta side. So from rack perspective, we are targeting 1RU, and it's going to be used for ORV3 as a starting point and 48 volt the input for this RMD. And from interface perspective, we are thinking of legacy interfaces, like 3 RS485 Modbus, and it's going to be used for the power shelf and BBU shelf, and multiple GPIOs, like power loss singular and backup singular indication, and one RJ45 for console, which is used for the debugging purpose, and it will be connected to BMC, and also there's a redirection to connect to CPU between the UART interface between BMC and the CPU. And also there will be some system LEDs to indicate the healthy status of the RMD. And we are also thinking of some new interfaces for future devices. The first one is the Ethernet. So the downlinks we are considering right now is based on Ethernet. So it's GE, and uplink is going to be 10G and 25G. So this is for future like power shelf for BBU shelf, and some of the LPU for liquid cooling controlling system. And potentially this can also be used for the out-of-band management switch in the future. And for GPIOs, we're also considering to have some more GPIOs, for example, like a liquid cooling controlling. If there's a leakage detected and there is some local action to shut down some of the main parts inside the rack, that can be done through some GPIOs. And also some other GPIOs for like ADC analog to digital converter to monitor the AC input signal, and also potentially to like send the power loss signal to BBU. And next page, please. Yeah, thank you. Yeah, for the RMD, we have a very rough diagram or proposal here. So BMC, for now, we are tending to take a look into this Run BMC module, which has been used on some of the Meta's switch platform, the latest one, like Minipack 2. And from CPU perspective, we are looking at the COM Express form factor, and also there will be security requirement as well. And from the interface perspective, we are proposing to have 2 I/O modules. One is for Ethernet, and one is for the next RS485 and GPIO singulars. And to fit this, in order to have a wider use cases, so we are thinking to have a 19-inch rack for this design, and then with a adaptive tray to fit into ORV3 rack. And also we added an OCP NIC form factor on the rear of this box. This is for the like more or better compatibility of future uplink connection in case if a future like top of rack switch may not support like 10G, 25G and Ethernet ports. Then this special NIC could help us to uplink to like 50G, 100G, or even higher for uplink connection. Yeah, thanks, Cindy.
We can't hear you, Mish.
Yeah, hello. Can you hear me?
Yes.
Yes. Once. Okay, now
I can share it.
Now you can share it. Yeah.
Yeah. But I think you should stop sharing it. It's not letting me.
Yeah, 1 second. I have to check which slides are shared now. Okay, let me share quickly. Okay, come back. Yeah, okay. Okay, yeah, so these are the requirements from the, yeah, these are the requirements from Google side. Yeah, targeting 1RU box as same as Meta and trying to fit it into 19-inch standard rack. From the front panel interfaces, we are mainly interested into 48 gigi ports. 10 mega speed is not mandatory, but 100 meg and 1G, they are like kind of mandatory with two 10 gig or 25 gig uplinks that is needed. In addition, for legacy interfaces, we are proposing to have two console interfaces, mainly one for BMC, one for CPU. If there is a space constraint, we can share one port only and toggle between these two. One port for RS485 Modbus interface and one reserved for CAN interface. So we are trying to have just a standard RJ45 interface 2x2 and consolidate these ports into that. In addition, we need to have a front power connector for 40 volt input. And in addition, maybe a reset switch and system LEDs that is needed on the front panel. So this is what is our requirement. Maybe going to the next slide. Can you go to next slide? Yeah. So here, based on the modular concept, that's what we are targeting to combine the requirements from Meta and Google. And as there is a little bit of a difference between the requirements, as well as there are some common things, we are proposing a modular design in which on the front panel will be done by using some of the IO cards, 1 or 2 or 3 different IO cards. So here we are proposing 2 IO cards, mainly Ethernet for Ethernet ports. So one IO card will support 24 Ethernet ports and will house actual Ethernet switch, third-party Ethernet switch that will do the switching functionality. And then for the remaining 24 ports, we are proposing to have another IO card, which may not have a switch ASIC, but it can have just a simple PHY or something. And we can route the signals from the first Ethernet card to that. So on front panel, in short, we will have 48 gigi ports, then 2x2 RJ45 interfaces, two connector for remaining interfaces, and power connector and LEDs. That will be on the front panel side. On the security side and BMC side, we are proposing to use Open BMC. For CPU module, a standard COM Express type 7 module that is common between Meta and us. That is kind of stuff. The other difference that we are proposing to use is that using the uplinks from the Ethernet switch itself, so that we don't have to add a NIC card in general. So that will help us to maybe have a less powerful CPU. That is the thing. And that's what is proposed at present. But just to future proof, we are proposing to add a space for OCP NIC in case needed. We can add that in future. And if future TOR doesn't support 10 gig or 25 gig, in that case, we can use the OCP NIC and the same board or the same product can be used as it is. Yeah. So this is a rough hardware proposal from us. So now coming back to the next slide, right, as we are proposing, yeah. Okay, so we are proposing a kind of modular design. So here is this diagram just roughly shows what is proposed. It is not the actual one, but so there will be 2 IO cards, one marked in like red. So this will be a first gigi. Then the second one will be a next gigi card, which may be kind of a dumb card with just PHYs. And the remaining things are like 2x2 RJ45 and power connector and so on. So this is kind of a modular stuff so that the same design can be shared between say Meta and Google. Just use whatever IO card you want. So for example, here it shows like we have IO card 1, which is doing say 24 gigi ports plus 2 10 gig uplinks. Then the second IO card, which will have say 16 RJ45s. And with that, like out of that, 8 will be RS485 ports and 8 will be for GPIOs. 8 RJ45s will be for GPIOs. So maybe in all, we can support up to 64 GPIOs. So for Google case, we will use 2 IO cards, both are Ethernet type. But for say Meta case, we can use IO card 1 and IO card 2, so that both the requirements can be met. And this RS485 can and CPU BMC consoles, they will be kind of a common interface available always on the front. Yeah, go ahead, go back to Sudhindra.
Yeah, Umesh, I think while sharing, mic gets disabled. Can you share again now? So
Yeah, okay, let me
that's what was happening, I think. So.
Yes, let me share 1 second. Okay, I think where are those? Yeah, I can share now.
Yeah, so I think there was a question on 24 ports. So yeah, as Umesh mentioned, right now the design is a modular design. So if we need more than 24 ports, we can use 2 of those IO cards. So essentially we'll get 48 1 gig ports. So this modular design and also these IO cards, if there are some other requirements, we can always add a new IO card. Right now, based on the requirements we have, these are the 2 we identified. But once we ask for feedback from vendors in the community, maybe more IO cards can be designed to meet the other use cases. Yeah, so coming to software stack, again, as I mentioned, this is still preliminary. We had few discussions on it, but looks like we will be going with Sonic because we would need a switching, complete switching stack, and it's a 1 gig out of band management switch. So then we need to integrate vendor SDK, and these will run on CPU, mainly the switch management software, vendor SDK, and the security code. And BMC will be open BMC. This is mainly for the firmware telemetry and to control the batteries and the PSUs. It can aggregate the Redfish and it can translate the Redfish if needed. If the northbound software cannot consume Redfish as it is, BMC can be used to translate it. And also there is a root of trust that is being basically can be connected to BMC, and it can provide the security end to end. Next slide, Manish. I think we are running out of time. So next slide.
Yeah, I think it is there, right? You can see.
So the next steps are essentially on the security side. We need to refine the requirements exactly and see.
We're not seeing the slides, folks. So I think it's Umesh who's sharing. Who's sharing?
Yeah, we have a problem.
Yeah, I think I'm sharing. You can see this, right? No?
No.
Maybe stop and start. Yeah.
Now also you don't see it because I'm sharing actually.
No.
Let me share again. Yeah, I think. Wow, it is not working. Maybe I'm not able to stop also.
All right, Hamid, can you, or can maybe Ling Jun, maybe you can take access back and then give it back.
Let me try.
Yeah, just
otherwise I can share.
Oh, there we go.
We can
see someone's.
Guys, let me put it on presentation mode.
Okay. Thank you.
Okay, let's move on. Thanks.
Yeah, go to the next one. It's the last slide. Yeah, so next step wise, we need to refine the security requirements and see if we can use DCSCM as the security as well as integrate DCSCM into it. And we need to see mechanically if that can fit into. And also we are discussing with Microsoft as to if their evaluate if their RMU, their rack manager, and the management switch use cases can be combined into this one. And also integrating DCSCM will enable some of their use case. And also we need to decide on which components to use, particularly the BMC hardware root of trust chip and also the CPU, and engage with vendors and community, get feedback and on the design, particularly based on the requirements that we have and what could be the cost of it. Okay, any questions?
Yeah, can I ask some quick questions?
Yeah, sure.
Yeah, so first, thank you for sharing this. This is great, and this product is very crucial. So my first question, so in terms of BMC, are you considering have redundant the BMC module in case of one BMC might be off, and because this one gonna take over the whole rack management. So is that one also be considered? Also,
Yeah, go ahead.
yeah. So yeah, second question. So are we going to also considering the communication between two or multiple RMD? So yeah, so that probably for the phase 2, but I just wondering whether that also be considered. So in terms of the one failure,
Yeah,
the one
so
can take over something like that. Yeah.
yeah, overall, I think the redundancy
Mhm.
aspect, I think we have not considered because the current use cases, I think, yeah, it is, but I think even on the hardware side, right, there are no two BMCs considered, or if the one RMD goes away, whether the second one should take over, maybe, yeah, I think we can consider that. Maybe we can have a discussion in terms of because also it will take space, right? If you are installing two RMDs in the rack, whether we have space for that. And also, if we lose telemetry for 5 minutes, is that a big concern? Because if the RMD goes for a reboot and comes back up, we may be losing the telemetry for a short period of time. But if we are loading, say, out of band management functionality, then maybe having a redundant switch is helpful because we cannot afford to lose that. So it's a good question, and maybe once these initial requirements are met, I think we should consider this.
Okay, thank you. So in terms of the future spec, so is there any schedule we probably can get both hardware and software, and is open to discuss, right? Still, not yet locked down yet. Yeah.
Yeah, exactly. So yeah, we are putting together a draft, and maybe in, let's say, coming months, we'll open it up for the feedback. Once we finalize at least the Meta and the Google use cases and the requirements, so that we can get feedback and make it more generic.
Okay, thank you. Thank you for your time. Yeah.
I have one general question. I believe, two versions of the spec was presented. One like called Meta version. The other one was the Google version. Can you guys clarify? Is it going to be finally migrated together, or is it like two modules that each one can use, or it would be entirely two different RMDs? I'm just asking to clarify.
Yeah.
For myself and the community.
Yeah. So Hamid, I think there are, because we see that there are some different requirements. That is why we are proposing a modular design. So those IO cards which are used by Meta and Google will be different based on the requirements. But the overall form factor, the components of, say, the BMC, the switching, or the CPU, those are all common. But there are some physical port differences. One needs RJ45 or another needs Modbus. So right now we identified two IO modules, one with the 24 port 1 gig and another one with GPIOs and the RS485s. And we are keeping it open so that we can add maybe more IO modules based on the other vendor use cases.
I'm not able to hear you.
You can't hear me, Umesh?
Yeah. We can hear you. I think some.
Any other questions?
Hey, Hamid, we are running a little bit behind
Yeah.
schedule right now. So let's see if we can kind of get back on track. And if there are any questions, please post them in the chat. And one of the project leads or one of the speakers can address them there. Sound good?
Yeah, sounds good.
All right, so our next presenter, I believe, is Will Stewart. Is that correct?
Yes, hello.
Hey, Will.
Can you guys see me?
Yes, we can.
Excellent. I'm going to share my screen. Can you see my screen?
We
Yes.
can. You might want to put it. Yep, perfect.
There we go. Cool. All right, and I know that we are running a little bit late right now, so we'll see if we can help out in moving it, getting a little bit more on schedule. So hello, everybody. My name is Will Stewart. I'm the industry segment manager for energy for Harding, and I am here with Jay Sandage, who is the director of marketing for Positronic. And we are going to talk to you about the AC input connector that supplies power to the power shelf. Both the updates that have happened in the last handful of months and where the suppliers are in getting these connectors ready. Here we go. So to start off, just a brief overview of how we got here with this connector. So in 2018, a joint development agreement was signed by the Open Compute Project and by various connector manufacturers and power shelf manufacturers to begin development and design of this input power connector. In 2019, the connection interface was designed. 2020 to today, we've been working on prototypes and updates and working on the language of the specification, all gearing up for the launch of the OpenRack V3. So it has been a long time coming. You can see it's been 5 years, and we are very excited for the actual launch. This presentation, like I said before, it will review the changes to the final specification and updates from the manufacturers. So starting with the manufacturer's updates, looking at the Harding design. So here you can see the Harding connector. And we will have products available, the bulkhead, the cable side or the plug side connector. We can sell both of those either as components or as a part of cable assemblies on either side. We do have samples available. Final product is available shortly. And as we look at our safety certifications, we're currently getting them approved both for UL and TUV. To talk about Positronic and Amphenol, I'm going to pass it over to Jay.
Hello, can everybody hear me okay?
Yeah,
I was having some audio issues earlier. You can go ahead and advance the animation there if you don't mind. Yeah, so as Will said, my name is Jay Sandage. I'm the Director of Marketing for Positronic, and I'm just going to give a brief update as to where we are on the AC input connector for our V3. As far as the products that are available, we do have both, the male side and the female side. The male side would be there's actually two versions that we have, which is one of them is a PCB mounted connector and the other one is a crimp style. So it'd be panel mounted on the power shelf, and it would have crimp contacts so that for those users that prefer to have wires running, from the panel into the inside of the power shelf. So both versions are available. In the picture, the male connector is the one on the left, let's say in the background, that has the contact tails facing up. And then the AC whip connector is the connector with the black hood installed on it. And then of course the crimp contacts there are in the foreground. So all these products are hard tooled. In fact, they've been hard tooled since 2020. And we've been shipping products since that time. And I would say probably in the last 3 to 4 months, there's been a major increase in order volume on these products, coming from the likes of a lot of the folks that have already presented earlier today. So we're proud to be able to support, this launch, as Will said. As far as safety certs, we do have UL and TUV already completed, and those are the file numbers. And if you needed any, if you need any more information, you can feel free to reach out to me and I can get you more information on that. You could advance the slide. And then as far as Amphenol CS, you may not know, but Positronic actually is part of the Amphenol family as of January of 2021. So we're still fairly new to the organization, but proud to be a part. And Amphenol CS is one of the many Amphenol companies, and they are also involved in this effort. They're making the same components that that we've referred to previously. They also have the AC whip available, just like Harding does. They are, as far as timeline, the products are hard tooled and they're in initial production, and they'll be shipping now. They're available now for those that are interested. And then as far as safety certifications, those are both work in process. And as you can see, the estimated time of completion is this month. So that's a positive development.
Cool. Great. So yeah, moving on, we want to talk about some of the specification updates so you guys can get an idea of kind of what we've been doing in the last couple of months, couple of years. So one of the topics that we had discussed is disconnect under load. So for a disconnect under load requirement, we initially stated in the specification that the connector must survive 50 cycles of insertion removal at 150% of the maximum rated current and voltage. This was language that was taken off of actually the rack PDU specification, IEC specification under input mains. And again, just to protect the equipment, obviously, to make sure that there's not going to be any, sort of degradation of the contacts in adverse, disconnection environments. However, one of the issues that we have with this is that we do not have a lot of room in the connector. There's not a lot of room between the back of the power shelf and the back of the rack. And that's really what you need in order to survive a condition like this, is you need more material on the connector and you need more space in between the connectors as well. And that's just something that was very, very limited. So what we were able to do in the interim is that, or not in the interim, instead of this, is we've applied a label. We're officially designating this connector as not intended for current interrupting. You can see the label that we've applied to the top of the connector. We also strongly urge other operators to make sure that there are processes in place to make sure that these don't get disconnected under load. In normal operation, this never ever should be, but just something that we wanted to bring up. It's not intended for current interruption. We do have the visual indicators, and like I said, we recommend putting processes in place to ensure that the connector is not disconnected under load. Another thing that we've been working on is actually the crimp contact. So I want to talk to you about an issue that we actually ran into. So if you guys are familiar with connectors, you're familiar that at rated voltage and at rated amperage, there should never be a temperature rise of more than 30 C or 30 K inside of the contact. But again, this is something that you are able to resolve by putting more material on the contact and just requiring more space. But this is very, very limited for space. And one of the applications that we were working on was actually for an operating temperature of 32 amps. We were looking at both the PCB and the crimp termination variant of the panel side bulkhead. And one of the issues that we were running into is while we were going for 32 amps, if we used a 10 gauge wire, so a wire or a cable with 10 gauge wires, we were having issues with actual cable routing throughout the rack. So one thing you can do is to obviously make the cable smaller, but using a 12 gauge wires, we were seeing this temperature rise of over 30 degrees C. So this is something that we were working on for a couple of months, and we had a lot of very interesting ideas, including putting holes all over the connector. So you can see in the top right, this is actually one test that Harding did with a bunch of holes on the connector to see if it would help with heat dissipation. It didn't. And just to clarify, this is not something that we're selling long-term. This is just a test that we did in the interim that I thought was interesting. How we were able to solve this actually wasn't on the cable side, but it was actually on the panel side. So we're going to go with crimp contacts with 8 gauge wires. And those 8 gauge wires, it allowed more material for the electricity to flow through and keep the temperature rise down. This again kept the temperature rise beneath 30 degrees C with the 12 gauge wires on the cable. Again, the 12 gauge wires allows for the easier routing through the rack. But one of the things to note is that we did use crimp contacts to fix this situation. So as data center operators and as power shelf manufacturers are considering, the type of power shelf and the type of connector that they're going to use, you should take into consideration the panel side connector and actually the termination that's going on to the PCB, and making sure that everything is up to code. I think crimp contacts with 8-gauge wires is probably the best one that we found for heat dissipation. And yeah, just wanted to say that to the community. So to keep going, I'm going to hand it off to Jay for the next two.
Yeah, and Steve and Dimitri had just asked that we do a quick summary of some of the actual changes or additions that we made to this particular part of the specification. So if you can go to the next slide, basically these 5 dimensions that I would say are fairly key. They were added, excuse me, they were added to the drawings for the male right angle PCB connector. So if you remember in an earlier slide, we were mentioning that there are 2 versions of the male connector, one which with crimp contacts and one with that terminates to a circuit board, using solder. So this is obviously a drawing of the PCB connector. And so those 5 dimensions that were added, the 2 that are on the left-hand side are basically positional dimensions for the 2 contacts. There are 2 lengths. So we have a standard length, and then we have what's called a first mate, which is, I presume everybody on the call probably understands the purpose of that. But that's the reason why there's 2 contacts shown there instead of just 1. It's because the center contact is a first mate, so it's longer than the rest of the contacts in the connector. And then we also, the dimension that's sort of in the middle is basically dimensioning the latch feature. The one below on the left is dimensioning the keyway, which had previously not been dimensioned. And then on the bottom right is essentially the position of what I'll just call like a locating pin or a locating node that is part of the plastic housing that just allows easy, let's say, insertion or location onto the circuit board so that it's orientated properly. So those were the 5 dimensions that the community asked that we provide, which we did. And then I think there was one other thing on the next slide that we had some conversations about wipe length. For those of you that don't live and breathe connectors every day, wipe length is essentially the amount of surface to surface engagement that you would have between a pin and a socket. And wipe length is a critical, let's say, mechanical aspect of any connector system. Typically, the more wipe you have, the better performance you can get. So anyway, so there was a discussion about making sure that the wipe length was recommended wipe length was listed, and so so we added this note to the specification for that purpose.
Yeah, cool. So I think that's everything that we have. If you guys have any questions about the connectors or where to get them or anything like that, please don't hesitate to reach out to us. You can see our contact information on the screen now, and it'll be available in the presentation after. Yeah, so thanks everybody.
Thank you, guys.
Thank you.
There are a few questions on the chat. If you guys don't mind, would you be able to respond on the chat so we can move forward to the next presentation?
Yeah, no problem.
Thank you so much. So Justin, what's the next presentation?
Yes, thank you very much. The next presentation is about the ORV3 AC power cord design. And up next is Dimitri from Meta and Nitesh from Amphenol.
Sure. Hey, everyone. My name is Dimitri Shapiro. I'm a mechanical engineer over at Meta, and I'm joined today by Nitesh Kannan, who's a technology development manager over at Amphenol. We're going to go over some of the work that we've done on the AC whip power cable development. So this leverages the connector that Jay and Will just spoke about and kind of morphs it into an overall power cord cable. So we'll just go brief overview of the design, the electrical aspects, mechanical aspects, a lot of the regulatory compliance that we have to conform by, and then timeline of availability of samples from Amphenol. So just an overview. So this will go over some of the technical requirements for the AC whip for power delivery that is in Meta's Open Rack V3 design. And for now, we have it as a Meta specific spec, but we're working on opening it up to be an OCP general spec.
Yeah, actually, Thanks, Dimitri. This is Natish. Probably some of us know me. I'm from Amphenol. I was in Boston before, so I think I'm from Amphenol. Yeah, so this basically it's our same. The connector we've been using the AC input connector, supplying it's supporting the three-phase wire connections in the wire. So we're gonna go over much deeper into that on the AC card design. We're using that connector as output connector.
Okay, so some comparisons between ORV2 and ORV3. So for ORV2, you can see in the picture here, we had a bulky PDU assembly that connects the busway to the power shelves, and it had some electronics in between to do that power conversion. Because of that PDU, we had potential points of failure, as well as you had fixed power shelf locations, which is kind of what Daryl spoke to earlier on the rack side. And you also could not expand. So you were locked into these two locations, and you couldn't move anything around. Whereas on ORV3, we have pretty much a simple cable solution that skips the PDU and goes directly from the busway in the data center to the power shelf. You can have multiple lengths to allow for different power shelf locations. So you can place your power shelf anywhere within the rack, and the different lengths that we have accommodate for all of that. You have easy serviceability, so you can just plug the cable, take it out of the rack, plug in a new one if you need to, instead of trying to disassemble an entire BVU or PDU, sorry. And you can also expand it so you can have two power shelves within a rack, or one power shelf as you need to. Quick overview of just the power shelves and the different why we have the two different versions of cables, right? We have a North America power shelf and then an EU power shelf. So North America uses two 20 amp breakers, and then EU uses one 32 amp breaker, and that leads to two different designs between the connectors and the overall cable itself. And also here a quick overview. So North America, like I mentioned, 20 amp to 277 480 volt AC. With the L22 20P plugs, which are shown right here, and then the EU version uses a 32 amp IEC 309 plug.
Yes, so we can have, in terms of electrical, actually, this AC card, we're supporting the both IEC and NEMO on the input from the AC card, power card input, which also, in the output we are using the 7-pin, the universal input connector for the other side of the power card. So if you can see the wiring configuration, actually, you can see the different termination, how the wire's been terminated. So the color codings is there, also the different cable standards. So it's been there. So this just shows the IEC and NEMO's different wire configurations. Dimitri. Yeah, so this is a connector just now, Jay and Will has been talking about. So I'm not going to much talk about that. It's the same thing. It supports all the different phase, different connections, star delta on single phase. As I mentioned about the central pin is it's a first made brake loss ground pin. As we know, some applications we've been using the male as whether it's a PCB or as a crimp version, because inside the panel. Yeah, so this you can see the polarity of the both connectors on the both side of the power card. As you can see, the NEMO is L22, the 20P or IEC, so both are both on the, so we can apply on the both cable assembly on both sides. So the in output connector polarity, as you can see, the number 2, 5, and 7 position, it's being a neutral, and then it can be spliced. You can have a different type of splicing that's open. So that is the main thing for this. So it's actually the color of the power card. You can see much more about the power card in coming slides.
Okay. some of the mechanical requirements. The first most important thing that we've seen is the way that you're encapsulating the connector that Nitesh mentioned earlier. So there's kind of two main ways to do it. One is through a two-piece plastic hood that Positronic developed, and then the other way is through an overmold. So basically, you're encapsulating the entrance of the power cord into the connector and kind of all the splicing that's in there. So the height of the overmold housing can be 24 millimeters maximum, and that's mostly based on routing it through the rack and kind of the space that we have there. And then for the plastic hood, it's 23 millimeters, just because it's a thinner plastic piece. From a meta perspective, we prefer a custom overmold just for reliability reasons and to make sure that everything is fully sealed off. But if a customer does want to go with the two-piece design, we do suggest having some kind of internal overmold to make sure that you don't have any exposed wires or anything that can potentially be damaged. In terms of cable lengths, these are based on three main positions within a rack, so top, middle, and bottom. But of course, the customer is open to placing their power shelf wherever they want, so they would pick a length that best suits their data center application. And of course, the vendors that you end up working with can also make a custom length if needed.
Yeah, I'm sorry. Some of them telling me my voice is distorted. I don't know why. It could be a combination, a little bit sick, and then I'm sorry about that. Okay, so in just what Dimitri mentioned about it's a two-piece solution versus overmold. Which is as you can see on the left, which is a two-piece, which you can see the some accessories with the cable ties, and you can see the cable directions, the power cord cable direction, how it's going. But if on the other side, this is a overmold solution that together with Meta and Amphenol we developed. It's already we already shipped some samples, and it's production is going on. So this you can see the cable from the exit, it's going parallel to the panel, so it just properly aligned. Smart mode thing. So that's the main difference.
Right. Some more mechanical basic requirements. So kind of what Nitesh touched on earlier, the 90-degree angle exit. So we basically want the cable to run parallel to the rear wall of the power shelf, and that's more so for easier routing within the rack and cable management. We have experimented with 100 degrees. But it makes it fairly difficult to route. But having the 90 degrees is also a challenge because of internal crimping requirements. So going off of that, the wire splitting and the crimping inside, there's many different ways to do it. There's splicing, there's different metal pieces that can be used to achieve splicing between different wires, mostly the neutral wire, because the neutral wire splits into 3 different pins. But the main requirement is that all the methods have to pass proper continuity and wire pull tests, as outlined in the spec, and then the safety requirements that Nitesh is going to speak about later. And then in terms of strain relief, we have to have a proper strain relief where the cable is basically exiting from the connector. And this is kind of why we prefer the overmold hood, because it provides that very solid strain relief in that area. And then safety warning label. Our requirement is to have a safety warning label on both top and bottom that says not for current interrupting, do not hot plug. And that kind of goes off of what Jay and Will mentioned earlier, that we're pretty much getting rid of the hot plug requirement for this connector. And then if a two-piece plastic hood is used, we want to make sure that there's no overmold in there to make sure that there's no wires exposed. And then for the power cord selection, this was one of the toughest things for this cable, and also kind of goes off of what Will mentioned earlier. So for the NEMA cable, it's pretty much straightforward. We use the SOW 12 gauge 5C standard. So the 5C stands for five wires inside of the cable, or an STW. So the only difference is one is rubber, one is PVC, but rubber is a little bit easier to route through the system, through the rack. And then for the IEC cable, it's a H07 RN-F 5G4 or 5G6 standard. So 6 millimeters squared cross section for each wire is recommended from an electrical and safety standpoint, just because it can handle higher currents. But when you try to route that 6mm square cable through the rack, it becomes very, very difficult, pretty much impossible. So that's why we went to the 4mm squared. And as Will mentioned earlier, the problem with that becomes the T-rise across the pins at 32 amps. So we had to do a lot of tests to ensure that this is not a problem. And we had to do some redesigns within the power shelf where we use thicker wire on the power shelf side connector, as well as having that be a crimp connector instead of PCB mounted. Because of that, we saw our T-rise was significantly below 30C, so we were able to achieve a solid design.
Yeah, thanks, Dimitri. You really touched on. Yeah, so mainly the regulatory compliance, because there are a lot of things in the actual spec. So we touch on a very key things here. As you know that we are this could be on a all over the world. So this we are qualifying this with the TUV and the UL as well, and UL and CUL. On top of TUV, we have a CE on the seats failure on the car as well. It's all harmonized, it's applicable to the harmonized standard. With and also the both the IC and power car should be it's industrial grade power cable, so conform to the other certification as well. So we can see that in the next page. Yeah, so these are all some of the things in an additional standard applicable for the parts of this one. So mainly the UL 1977, which is the connector is already been qualified for the things, and then the power card, the UL 62 is another thing. So of course, it's IPC, WHME, the entire cable assembly need to be make sure follow that standard. So basically, there are more details, like the mechanical and other stuffs in the spec, which could be more in the spec on in terms of quality control process and even the production. So much more in the spec. So we touch on these key things here only. Okay. Yeah, here is a timeline from Amphenol in terms of connector availability, and then the cable assembly, the ACV assembly. We've been already told, and I would really appreciate the real appreciation goes to the Amphenol team, especially Bob, Carmelo, and Steve, and some of the engineering team put the effort to make this thing complete on time, because the period was very short. But anyway, so we are in a good, we have very good progress right now. Our safety certification is going on. By end of this month, it will be done. So this is some of the things we produced, and we are shipping it for initial testing and pre-production stage right now. So more or less by end of this month, all our safety certification will be done. So it will be, we are already shipping some samples. So if anything needed, any help, we can please approach us. And again, thanks to the team. Yeah, thanks everyone. Any questions? You can shoot us. We try to speed up. I don't know whether it help or not, Ashna. I'm sorry.
No, thank you guys very much. I don't see any additional comments in the chat. Some may come in, so we'll keep an eye on that. And perhaps if anything does come in on the topic, you guys can jump in and provide the answers or response.
Okay, sure.
Let's see, next up on the list here in the agenda is the OpenRack V3 IT gear input, 48 volt, and the power shelf output connector. So we've got Brian Costello from TE and Steve Pressel from Amphenol. Are you guys out there?
Yes, we're here. Can you hear audio and see the slide?
Audio is good. Don't see a slide yet.
Can you see a slide now?
No, sir.
Okay, got it on my.
With Zoom, sometimes you have to select it and then hit share in a button that's in the lower right-hand corner. I don't know if that is perhaps the issue.
I can see it on my end, so please let me know if you see the slide.
Not yet.
You want me to give it a try?
You might have to, Brian. I just toggle between all the settings and I'm not sure why it's not showing.
Oh, there we go. We see someone slide.
That's probably mine.
Okay. Brian, you're good to go.
Okay. Actually, this is Steve Presswell from Amphenol, engineering manager. I'm going to lead off. Brian's slides are later in the presentation. I'm going to cover the output power connector. Brian's going to provide updates on the IT gear connector. You can jump ahead, Brian. Thank you. The most notable change on the power connector since the summit in November has been the increased gatherability on the connector. This aligns to the connector and the bus bar. The bus bar updates will be in later presentations. But looking at the slide on the left, in November, the connector had a symmetric fork tips, if you will, on the connector. The view on the right shows the larger gatherability now has an asymmetric fork tip. And because of this change, the connector was increased. That was due to steel safe changes at the time. So the length of the connector tips increased to achieve this larger gatherability. Next slide, Brian. Here in the views on the right, these are the dimension views that are currently in the spec that's uploaded to the wiki. The dimension that I just referenced earlier is the 29.85 dimension shown in the upper left view. And then the detail A in the lower right is the updated dimensioning scheme for the larger gatherability and the critical dimensions to assure the tolerance analysis plays out. Some additional updates to the spec. The plating has been defined in the spec. So the power contacts are to be plated with silver over nickel in the bus bar mating zone. And the chassis ground contacts are to be plated with matte tin over nickel in the bus bar ground mating zone. Last bullet here on the left is just referencing the tolerancing and dimension updates that have been made to the views shown here, which again are shown in the spec and uploaded. Next slide. An additional change has been mounting hardware. So the fasteners are now called out at a 6mm max head diameter, as well as a 2.5mm max head height. You'll see more in the bus bar updates as to why this was made, but this aligns to the bus bar updates. An additional change has been the washer thickness has been increased from 0.5mm thick to a 1mm thick washer. Next slide. Additional change has been the addition of datum D. Datum D on this view and in this spec ties to the overall spec. So this is tied, referenced in other specs, tied back to this spec as well as the IT gear. And the 14.2 dimension, which was in previous spec, has been updated to 14 plus or minus 0.1. This was to align to plus or minus 3mm float on the connector. As it was dimensioned previously, the float could exceed the 3mm. So this was a tolerancing update to align to the float specs. I believe with this, it's from here on out, it's Brian in the IT gear. Yes.
Okay, great. Thanks, Steve. And so I want to go over some of the changes, both the screw mount design and most of we'll talk about the tool list because there were some significant changes to that. First on the screw mount design, as Steve had mentioned, we had added a datum. We added some datums to the panel mount cutout, so we have added datum D. And we implemented the same changes that Steve kind of went into as far as the gatherability. So the mating interface on both connectors or that lead-in edge are identical. Likewise, on the screw mount design, the washers, as Steve pointed out, we all specified a 1 millimeter thick. There were some issues initially where we had vendors using thinner washers, and then that became some issues. So we increased that as well as the screw head diameter to make sure we avoid any interferences. So that's basically the same on both connectors. And so on the tool list design, we did have some significant changes. And so the overall width was reduced. It was 62.2. Now we're down to 55. So we have the same dimensional width as we do on the screw mount design. And another thing that we did implement, we did make an adjustment on the dimensioning, and this is actually true for both the tool list and the screw mount design, whereas we were really dimensioning all of the features, the contact points from the primary datum, and we changed that into really defining the power sense and the ground sense return, really basing it off of the location of the power and ground return. So that made sure that you couldn't have tolerances go opposite directions and then lose the amount of lead-in or white distance that we had or spacing between the sensing and the actual contacts. So that was an update for this design. And so we also made some changes on the locking features. We actually made the openings in the panel narrower and the features narrower, and that was designed to avoid any possible problems when loading the connector into the rack or into the panel, that you would have the ability with the lock retracted, to have the grounding features offset from the and possibly stub condition. And so the other most other features, we talked also about on the power, as far as datums, we have the datum D, as we talked about, on the screw mount design, same for the panel mount, or the tool list design. And so I was going to just go over I had a few questions come in from on the way the connector kind of goes into the panel, so as it approaches, it's shifted off to one side. And in that point, the locking feature is retracted. And then as you slide it over, as you get into the free area, the locking feature is engaged forward, which prevents the connector from being able to get back into that position where the upper and lower panel retainment features, are behind metal, so they cannot be come back out. And this also, the feature dimensions are geared, to make sure we have the rotation is controlled, so that we don't have any further than the screw mount connector. So once it's locked in place, and removing it from the panel, just the opposite. Where we retract the lock, slide the connector over, and it can be removed. So both insertion and removal all done, without any tools, and it can all be done from the inside of the panel. We had some questions about that, whether that would be required to have access to the rear side, and you do not. It can all be done from the back side. And lastly, on the panel, these features, were updated as far as the overall width, because we reduced the size of the locking feature. And then we also tightened up some dimensions, to kind of get the overall ability for the connector to float in both. Really, it's controlled by the outside features, but we made some adjustments to also make that the same for kind of all of the features that kind of would end up touching off on the connector. And again, as we talked about, we added a datum that then aligns to the overall IT gear specification. That's all I have. Any questions on either connector? If not, I'll pass it back.
Great, thank you, Brian. Yeah, just keep an eye out on the chat if you don't mind, in case any questions come up after this session, so we can address those.
Okay.
Let's see. Next up on the agenda, we are catching up here. We're just a little bit behind. We have Dimitri from Meta up for an encore appearance, and Mike from Amphenol talking specifically about the bus bar. So, gentlemen, the floor is yours.
All right. Sorry. Hey, everyone. My name's Dimitri Shapiro again, mechanical engineer at Meta, and I'm joined by Mike Wingard from Amphenol. So we're going to go over some of the improvements that were done to the ORV3 bus bar since the last development. Right. So comparison of ORV2 and ORV3. So for ORV2, we had pretty much a fixed connection from the power shelf to the bus bar. And we had 2 power zones and 12 and 48 volt bus bars. And by design, we didn't really have a touch-proof design on the bus bars for ORV2. And then we also had a gatherability tolerance of plus or minus 2 millimeters. And then, so on ORV3, we made a lot of improvements. As you guys know, the power shelf can go in pretty much any location. So that allows for a bus bar that is full length instead of 2 different lengths. So we have 1 power zone that covers everything. And it's pretty much 48 volt only. We have a touch-proof requirement that basically means you can't touch any conductors on the bus bar. We have a direct ground path from connectors to the rack that goes to the bus bar, and we have a gatherability of plus or minus 3 millimeters. Right, Mike?
What we're showing you here is the ORV2 12 volt spec. I'm not going to go into a lot of detail. Most people, I believe, are fairly familiar with this. Maybe we could go to the next slide to the 48 volt. The 48 volt version in ORV2 is depicted like this. And some features I want to point out, because they're going to be very different from ORV3, is if you look at the front end, the snout there with the insulator and the bus bars, you see how close the bus bars are, and the snout is to the opening of the cage itself. And also the gatherability is fairly simple. It's pretty much just an angular gatherability. These are some of the areas that will change in the ORV3. Next slide, please. So as you can see, a lot more dimensions have been defined in ORV3. The key dimensions that I want to point out are the 10.3 millimeter dimension that you find in the upper left-hand side, showing the extension now of the insulator out a little beyond the cage. This is to enhance the gatherability, as was pointed out in the connectors, where they show the asymmetry of their snout. This helps to gather that before plugging into the bus bar. And because of that, a few other dimensions had to change. There's the 18.25 that was 18.35, that's up at the top. And also at the bottom, the 27.05 was 26.65. So what it in essence does is it helps to engage the connector much quicker, and also allow for the full 3 millimeter gatherability. Along with that, you see that the snout on the cage side has changed as well, and that's there depicted in detail A up in the upper right hand corner. So it's more than just a straight angular entry. There's some radiuses there to help bring the connector into alignment, and we've also seen this work very well so far. In detail B is another feature that was pointed out in the connectors presentation, and that is the clearance allowance for the head of the screws for the screw and washer design for the float for the connector. We found that due to tolerancing, there could potentially be an interference fit that would prevent a full mate between connector and bus bar. So in the bus bar design, we've notched those entry points there to allow for full unrestricted float of the connector so that the screw does not interfere with the cage. Dimitri?
Sure. Yep. Thanks, Mike. Overview comparison over ORV2 and ORV3 profiles. So you can see these guides that we had on the outside for ORV2 were non-conductive, so they pretty much just acted as guides. Whereas the guides that we have on ORV3 are actually conductive, and they provide grounding from the chassis to the bus bar, and then further onto the rack. This bus bar on ORV2 was not touch proof, so you see there's a pretty open gap, and the conductors are fairly close to the front, so you could get your fingers in there potentially. Whereas on ORV3, we moved the conductors back, and we made sure that pretty much at all angles of entry through a standard UL probe, you are not able to touch these conductors. And then we have a cover on ORV2 around this area. On ORV3, we have the same. Some other features of ORV3, the chassis ground connection to the rack is through these tabs on the base. So we have a screw with tooth washers. So that washer kind of grinds into the metal in there and then connects to the screw, and then the screw connects to the nutsert that's on the rack. And then, yeah, then the clearance Mike mentioned earlier as well. And then also the improved gatherability that we have for the connectors. Some recent designs and some design improvements that we've done on ORV3. So right now we are in our DVT stage. So these are improvements that we've done from EVT to DVT. So initially we had at the top mounting, we had 2 thread forming screws to connect it to the top canopy. And what we saw is that these are fairly easy to strip, as a lot of thread forming screws are. So we changed that to 3 PEM nuts to make for a much easier installation. We also saw some potential bowing of the bus bar during transportation. So the 3 contact points are supposed to also improve the retention of the bus bar and basically remove the potential for bowing, because you have those 3 points lining everything up. Okay, and then we also, due to that deformation that I mentioned earlier, we also wanted to stiffen up the alignment brackets that we have at the top of the bus bar. So we made them wider, and then we added 2 M-bosses to each side, basically to stiffen up that area after doing a lot of FEA to prove out many different designs. And then, yeah, some of the design improvements that we've done to the profile. So like we mentioned earlier, the larger opening for improved connector gatherability on these ground contacts, the cutouts for the screw mounting clearance. Also, to improve stiffness of the bus bar and reduce potential twisting, we have larger supports in these areas for where the copper assembly mounts to the overall sheet metal. And then also we added extra copper blocks, or I guess we increased the size of this area in the back to allow for less voltage drop and less temperature rise based on some of the testing that we've done. All right, Mike.
And we have also developed test bus bars for both the 500 amp and the 150 amp connectors. This was primarily due to requests from the connector companies for qualifying their connectors. But what we've also seen is that some of our other customers want to test their IT gear before sliding it into their racks. And these you can set up on a bench, slide in your IT gear, power it up, and make sure everything's working fine before installing it into your racks. So both of these are also available. And these are the reference specs. There will be an update to the last one there. that it will include the tabs and the 3 holes versus 2 holes. That's coming in what, about a month, Dimitri?
Yeah, about a month or two. Our goal is to update the busbar interface spec to have all the latest mounting references and all the changes that we just discussed. All right.
Thank you.
Yeah, thank you.
Thank you guys very much. Appreciate that. Let's see, it's 11:15 local time in at least Pacific Standard Time. So we're actually on pace here. The next couple of sessions is really kind of designed to be one integrated session. I just have a few slides to kind of guide that conversation, which I'll share right now. If you don't mind, I'd like to have myself and Hamid and Steve Mills and some of the other leadership of Rack and Power come off mute here, just because this is intended to have a kind of a community discussion and any leftover questions that may have existed from the previous presentations here. So I will go ahead and share my screen. Share. Let's see here. Am I visible?
Yes, you are.
Active slides.
Yes.
All right, great. So the community discussion is really centered on a couple things. What should the community here within the Rack and Power group, what should we work on next? And from a leadership perspective, as project co-leads and IC representatives, what can we do better in terms of engaging with the community, in terms of outreach, in terms of bringing more people into the OCP community and making OCP more, Rack and Power more relevant to some of the other IT users and consumers out there. So just to frame that conversation a little bit, some of the examples that I've heard just in my conversations leading up to my participation in the group, talking to other customers, other potential users and interested parties are a few things like this. We talked a little bit earlier during the Rack and Power conversation about 19-inch hardware support. People would like more granular details about that and maybe more traditional support for those consumers who are more used to what a traditional server cabinet deployment looks like, at least on the rack frame side. Also, in terms of the rack frame conversation, considerations for things like multi-rack deployments. So if we have let's say an HPC type provider or another company who sells systems in let's say variants of 4 cabinets or 8 cabinets or 16 cabinets as a part of an integrated system, is there any plan within OCP to make considerations for the resources that need to be shared within those cabinets, right, as sort of like a pod? Is there any plan for something like that? And there's also some conversation, or at least I've heard some conversation about the boundaries of a spec, right? So what's hard-coded in a spec and what's flexible? I think there's been some good conversations today about, an example of, you've heard a lot of the term meta contribution versus spec language, right? So we know what Meta is looking to do and what they need the OCP design to do, specifically like their OCP rack specification being 44 OU. But the spec itself is not going to say that you need to build or you need to consume a 44 OU rack, right? So there is kind of both there's the letter of the law with the spec, and then there's some, what's flexible is kind of the creative license that a user or a manufacturer could provide. If we think about just one element of that, so like kind of 19-inch hardware support or traditional hardware support, we looked at this table before where 2 of these items are highlighted: RU gear support in OpenRack v2 and the quantity of OpenRack gear supported or RU supported. And it says no and it says none. But there is, a marketplace out there on the OCP website where providers are highlighting marketplace RU conversion shelves, right? So these are 2 options that are out there on the OCP marketplace today which would allow someone who consumes or who buys an OCP V2 rack today to perhaps deploy some 19-inch hardware within an OCP rack. Of course, there are the distinctions about where you mount the power sources for those hardware and such, but that opportunity exists out there in the marketplace. And as Steve mentioned, for ORV3, there's an opportunity for a company or an organization to step up and to be that contributor for an adapter kit for the 19-inch rails, knowing that we have or 19-inch equipment, knowing that we have the RU part of the structure built into the frame. So that's something to consider about the support of traditional 19-inch or RU hardware within OCP racks. If we take a look at what ORV2 had in terms of its power shelf and equipment shelf configuration, the frame profile here versus the 6OU slice that we have available on the wiki today for download, you can see the different compositions of the OU and RU mounting holes versus what exists here today in ORV2. So there is the ability to accomplish that, and there's ability for a company to step up and contribute a design file for a 19-inch adapter kit or something else to fit that ecosystem of products. Getting back to this, one thing that was a hallmark of the Open Rack frame presentation, providing that flexible solution to scale across different industry needs. I think what Steve and Daryl showed during their presentation was that progressing into other types of applications for maybe customers who go into colo or operate their own company-owned enterprise facility is that you're starting to see the advent of traditional accessories that maybe traditional server cabinets have used and bringing that into the OCP landscape, right? So front and rear doors, airflow management, sidewalls, the seismic bracket kit, a lot of these things, like I'm showing now, that that a traditional cabinet or rack has included are now becoming more normal for OCP racks. So if there are security requirements, if there are unique airflow requirements as part of a containment environment, there are provisions for that here within ORV3. So we're happy about moving the rack design from what was a little bit more restrictive in ORV2 to making it a lot more open and a lot more flexible in ORV3. And then in terms of spec boundaries, just that note before about what Meta's contribution will be to the community versus what the spec language will say. So there's flexibility and openness for a manufacturer or consumer to deploy some creative license with things like height and some other elements, whereas the spec will note those critical dimensions and those critical tolerances that have to be maintained as part of the specification language. So those are just some things that I wanted to highlight that I've seen that are appropriate discussion questions or have been relevant discussion questions in and out of the group conversations. We'd like to open it up to the floor now just to see if there are any other questions or comments, feedback that we could get from the community. So please feel free to either put them in the chat or to unmute yourself and ask away.
One item that I would like to clarify is around the specs is that, the specs that so far has been shown and presented is the meta, I will call them the meta version of the spec. We kind of, on this Open Rack V3, we started with a very detailed design of the spec, but now we are actually going back to build the base specs. They are not ready yet, but we would like more other hyperscalers to also contribute on the base spec. the base specs so for all of the rack, PowerShell, PBU would be much more flexible, and doesn't have all the limitations that are currently available on the Meta version. Meta version would be a subdivision of the base spec, so it should meet the base spec, and it has more requirement and restrictions for the Meta purpose. Others could just use the Meta version, or just go and also, or make another branch from the base spec. We are working with a few other hyperscalers to develop the base spec. I'm here again encouraging the companies that are interested to work to develop the best spec together. Just want to clarify this piece of confusion that might be out there.
Yes, thank you, Hamid. That's a really good point. Several good points, and it really brings home kind of the ambiguity that exists in some minds about what exactly spec means, right? And the delineation between an open compute spec versus what Meta wants to use within their own facilities as regards to these products. Steve, did you have any comments either on that point or some of the items I highlighted earlier about contributions and things of that nature?
Yeah, sure. Philosophically, in the base spec, right, we want to ensure the IT gear and power shelves, et cetera, are intermatable with the rack infrastructure. So that's really philosophical. We want to define just enough for those components that they're interoperable, and leave the rest of that open to the community to go build on top of. I'd really like to hear some more about, from the community on maybe some enterprise features that they're looking for, or anything related to like a roadmap. What does the community want to see next after we deliver this stuff later this year?
I'll jump in a little bit. We just recently adopted kind of OCP, or working towards OCP, and one of my initial frustrations was there's not a lot of things. There's a lot of barriers to entry, things around like top of rack switch sleds and how that interacts into the bus bar, and okay, that needs to be designed from scratch, and there's no reference design for like a power interposer board, and how is kind of more of an enterprisey system integrator supposed to approach that when they want to use kind of motherboards from the channel. There's no reference design for just a generic sled, so that someone can throw some drives, throw a board in, and make that work. Other things like the PMC, right? There's a lot of focus on I believe it's the PMI, which is more Modbus, whereas a lot of people don't really have that command and control functionality, don't have a rack management, anything, and are really looking for kind of an IP-based interface that they can plug into their more enterprisey management systems. WIP reference designs for those of us who are kind of stuck in colo versus our own facilities, so have to deal more with kind of your 208 volt type environments. Having a reference design for that would be fantastic. And things around, certainly the holy grail is like the 480 277 volt, but most multi-tenant wholesale data center facilities are not familiar with that. It's scary to them, and there's no reference design that you can point at, to say these are the components that have been proven and tested and fault current is good and all that stuff. There's a huge barrier to entry there. So these are just kind of things as we've approached it, as PlayStation has approached, adopting some of these technologies, they've been hurdles, and not many companies are kind of willing to take those steps. It involves investment, it involves partnering with different ODMs, and so we're certainly looking to kind of contribute our learnings once they become mature and they're tested. But those are just some things I wanted to point out.
Yeah, Colin, those are all good. So hopefully the IT gear reference design that's on the roadmap coming out later this year will be helpful, at least towards helping IT gear builders build I've gotten lots of requests for the PDB design that, you know, everybody wants one, but so far nobody has contributed one, but there's definitely a lot of demand in the community for that in terms of enabling off-the-shelf stuff. So hopefully we can get some people to work on that. Yeah, some of the other things you talked about, like a 208 volt reference design, I think that would be very useful as well.
This is Lang Vu from Lydon. I want to add that to the question, if there's something different than a PMI. We recognize that OCP defined it as a with the PMI with the Modbus and the top of the rack talking directly to the PSU. So we also, I mean, many companies also develop we call PMC, which is exactly what you said, that it can talk to the power supply via I2C, and then top of the rack can talk to it through Ethernet, Redfish, I mean, SNMP stuff.
Yeah, it's interesting to hear that Lydon has a product. I know that Delta has a product as well. In our use case, we're actually home running the connection to that PMC because our intent is to turn the racks completely off when no longer needed, right? We have kind of a pretty big sine wave in gaming as far as utilization of the racks. And as part of our power management strategy, we really want to turn it off, and therefore we have to do that from an external connection, not from the top of rack. But it's good to know Lydon has a product. That's interesting.
Yeah, maybe just to add to that, the design of the power shelf, we intentionally left that module power management like board as a flexible design, because we knew that this communication to the power supplies and PPUs, there is no standard around it. So everybody likes to do their own way, and there might be different use case for that. That's why it is a modular compared to V2, but that was hard design. We did so the meta version of on the meta side, we just focus on the PMI version, which is communication to the Modbus. We did progress slightly on the PMC communication to Ethernet. We didn't push it to like as a meta, I would say. We didn't push it to like a production because we didn't have a use case. But actually, we did go up to even the schematic level with one of the vendors. So I encourage anybody interested. We were hoping that like that vendor could contribute to OCP. It was not a power supply vendor, but I would encourage again the contributor to come and work on a spec and then build the product around that. Yeah, I see Lydon has a product. Delta seems to have a product that vendor has, which was given product. It might be good that you guys get together and build a spec around this, and that could be a one single common spec for a PMC, and everybody just build a product around that. I think that's very useful, Ethernet based. It just we didn't at the meta we didn't have the use case for it, so we didn't follow. But I'm pretty sure this is a very valuable piece and could be used for other applications. Regarding the like turning off the rack that you mentioned, Colin, yeah, that's a good area. How do you want to like you want another switch which is not power from the rack to be able to turn off the rack? Is this the thought?
Yeah, the thought would be that there'd be some kind of, I'm assuming that the PMC would have some kind of standby power, and we'd want to de-energize the bus bar So all the switches and all the equipment in the rack, we'd want to turn that off and just leave the PMC and the power shelf active.
Yeah, that that piece is possible that you turn off output voltage of the power shelves, and you need also, if you have battery, you need also command batteries not to turn on, or the PMC or even PMI should be able to work. It just the other device that is commanding has to be out of the rack, because like once you turn off the bus bar, like that device is not powered anymore.
Yeah, so we imagine that yeah, we home run copper to that PMC. It's connected to a management network. We have a device there that's managing kind of our power management algorithm that based on our capacity needs and the uptick of the service, we either turn off or turn on racks in an intelligent way.
Yeah, as long as you have that device out of the rack that's powered, that shouldn't be a problem. Adding this feature to the PowerShell, even through the Modbus, you could do that through the internet. Definitely, you can do that. So I think that you have a good use case that you want to shut down the rack, and we can add feature around this, even like through commands to shut down the output voltage. But PSUs is still working, but not delivering any output voltage. That should be not relatively easy to implement.
Excellent.
Yeah, we can work together. We can discuss offline later on this feature.
Okay, sounds good.
Yeah, regarding, I like to go back to this topic that Justin brought up. Now, what topic should the community work on next? And how does the rack and power could do better? Our focus over the last at least 2 years or 3 years has been Open Rack V3 and all of these subcomponents. We recently added RMU, or call it RMD, the communication piece that is not really a piece attached to Open Rack V3, but it could be used for any other application as well. I like to understand and get feedback from the community around these two questions. What do you think that the community should focus next, and what area we can do better? What are the thoughts out there? I know most people should be tired by now, but I appreciate people jump in and provide feedback.
Yeah, I think we may need to let a few people go to lunch. I mean, become reinvigorated. But that question for us is essential. It helps us stay viable. It helps us grow, and this is a community where the very innovative and creative community. So that's definitely something that we want to cultivate, something we want to tap into. So our inboxes, of course, are always open. One of the things that we wanted to highlight, of course, was how to get involved. And so you can see the URL here for the Rack and Power group. I suspect many of you are on there, but in case you're not, head over there. You can subscribe to the mailing list, and that's also where you'll see under specification and designs when we were talking about all of the updates. I particularly highlighted the frame and CAD references that Daryl talked about before. But indeed, all of the power specifications or power files, many of which were also updated in April, are there as well. So you can have the latest and greatest info there for you to digest, and come back with more feedback and questions, and attending the monthly meeting. So the monthly calls are on the second Wednesday of each month. The meeting for next week has been canceled just because we were all convened here today to get the latest and greatest from all of the contributors. So the next call is June 8th of this year. There's the email for both myself and Hamid. So I guess I'll I'll close my part just by saying I hope we conveyed during this presentation that a lot of very technical subjects, but it's important. You can see the importance of how they all must seamlessly interlock and work together, right? To provide, the environment that we want to provide, safety for the electrical components, to provide, ease of use and flexibility for the operators. There are a lot of pieces and interconnects, to use a popular word, that have to come together to make this a successful deployment when it hits the white space. So we're very appreciative of all of the contributors, the volunteer presenters here from their individual organizations. And so we thank you guys very much. Hamid, Steve, Colin, anything else you guys like to say in conclusion?
Very well. I echo it again. Thank you so much, the presenters to contribute today, and also thank you from the OCP Foundation, Archana, and the rest of the team who supported this presentation today, and everybody else who were active and provided questions, comments, and feedback.
Hamid? Yeah, a couple of things. Number one, yeah, very, very many thanks to everyone that attended. The recording, as well as the chat transcript, as well as the presentations, will all be online. Hopefully in the next couple of days. We're going to try and get to them as quickly as we can. So we appreciate your patience. They will be on the past events page, and it's on the OCP website. So that's number one. We are continuing our networking series next week. So there'll be 3 days of networking tech talks. The reason that we're doing these all separated is so that we can get some cross-pollination across all of the other projects and allow, this team here to attend other calls, whether it's hardware management for rack managers or data center facilities, to see how these racks and are getting incorporated into the data center. So there's a lot of different tech talks going on. Please do check our website and register. Similar kind of interactive sessions, similar format. So hopefully, we'll see you online there. But many, many thanks to our volunteer leaders here. They worked so hard to get this agenda going, and appreciate the work that they're doing. And of course, Kate and Kaylee behind the scenes for managing all of the interaction between the folks. So thank you, everyone. Have a wonderful, wonderful day. Thank you for staying over another 13 minutes. We really appreciate it.